internal session chair? Yeah, who is going to present the paper? Will it be presented by? Abhinav, okay. So, uh, yeah. So we have Mr. Vivek Ahuja joining us as an external chair for this session, and we have Professor Ashok Kumar as an internal chair. He's heading Center of Excellence, Artificial Intelligence with Sharda University. So I request now Abhinav to come forward and present his paper on acoustic signal processing and communication. Please.
Three now. Who's got it? One? Yes. Okay. It's not working. A very good morning, all. I'm going to present my topic, acoustic signal processing communication, topic modeling of Scopus abstracts from 2010 till 2024. So our paper basically explores past 14 years topics which are dominant in research and concerning acoustic signal processing and communication using AI-based topic modeling approach. So I will just give you a briefly introduction about how acoustic signal processing and communication works. Basically, input source signal acquisition is there, pre-processing, and digital signal processing, communication system, signal reception, demodulation, and after out processing, where we convert digital system to digital signals to analog signals. So basically, topic modeling approach is an algorithm which is designed to extract the topics from the corpus. Like we have large amount of corpus and we can extract the topics from there only. So basically it is an unsupervised learning. We don't have to give labels to the data set. It by itself extract the topics from the corpus. So there are some topic modeling algorithms are there. First one is latent dielectric allocation, then non-negative matrix factorization, then third one is Burr topic, and fourth, latent semantic analysis. For our research work, we use the Burr topic algorithm to extract the topics from the corpus. So basically, Burr stands for bidirectional encoder representation from transformers. So basically, this is an AI-based system which is used to extract the extract the text from the corpus. So this was the system configuration we worked on. Basically, we were working on the Python-based Python programs like Burr topics, scikit-learn, UMap, and HBD scan, and also the catch of our study that we already use the pre-trained neural network, that is all mini LM L6 V2. So basic methodology of our research was we were doing the data preparation, generation of the word clouds, sentence transformers, sentence embedding, dimensionality reductions, and clustering. So in the data preparation, basically, we have generated our data using the Scopus API. We use the query like acoustic and signals and processing and communication. And on the left-hand side, you can see, based on this query, we got the results that how much research is going on related to these topics since 2010 till 2024. Initially, we got the 5,105 papers. Then we excluded the papers where abstracts were not there. So in the end, we were working on the 3,435 papers. So next step was the generation of the words. Basically, the maximum size is given to the word represents the maximum, the size, the text size, which is the larger one, which shows that the frequency of the word was there. So the size of each word represents its frequency in the text data in the corpus. And after this, we use the sentence transformation and sentence embedding method. In this, already we use the pre-trained all-mini LM L6V2 model, which is available on Hugging Face. And from there, we converted the sentence data into the vectors. And the conversion of this sentence to the vector, it is known as the sentence embedding method. And it transformed, basically, the model already have this dimension. It transformed the input text into 384 dimensional dense vectors, which is compact, efficient, and efficient version suitable for a variety of tasks, including clustering, semantic search, and topic modeling. Next is the dimensionality reduction. For more, we can say we use the dimensional reduction quality so that we can get the more, our model get the more interpretations, and we utilize uniform manifold approximation and projection method. And in the end, we use the clustering method, which is SDB scan, basically hierarchical density-based spatial clustering of application with noise. So in the results, finally, on the first run, we found that these are on the left side, you can see, these were the topics which were frequently coming, and we calculated this using TF-IDF algorithm. Basically, TF-IDF stands for term frequency, inverse document frequency. More the TF-IDF value, it shows that the more the significant word is, and the less shows the less relevancy of the word. So basically, this is on the single run, you can see the curves on the since 2010 to 2022 or 24. We can see that the graph of the showing that the maximum peaks shows the result was at the time of the peak, and it was the hot topic at the time of the in the particular year. In the cosine similarity between topics, like we have given, zero speech model training recognition, and it is compared with the zero speech model training recognition. And we have seen that there is a correlation between all the topics, and the points represent how much these topics are correlated to each other. Now, for the more stability, we run our topic for the 10 epochs, basically. And we found that the topic is defined as stable if it is present more than 50% of the repeated runs. Like in the first runs, in the 7 topics, first 2 topics repeatedly were coming in the runs, like speech, acoustic recognition training, underwater acoustic communication. So basically, we find that our 2 topics appeared in 10 runs, remaining topics each appeared in 9, 8, 6, 4, and 2 runs. So if we consider the topic that appeared less than 5 runs, then it is an unstable topic. And we obtained the topmost 5 topics, the most stable ones. Basically, this graph shows the standard deviations and across the 10 runs. And in the end, I will conclude that we can use BERT topic modeling for the meaningful related topic research. We can find topics and make it easy. Like we don't have to go through the papers, lots of paper. Like we can generate meaningful topics like we did it for the acoustic signal processing and communication. And in the last, I will say, a bird topic can provide a major topic and interested in the field. Thank you. Any questions? Sir, any question? Actually, sir, we don't have to go through lots of lots of research work. Like in real time, we don't. In real time, that we don't have to that much of time that we are going through thousands of papers at a time. So what actually it does, it allows us to, when we run the topics related to our query, we can get how much currently hot topics are going on, and what kind of research is going on that particular topic. So it is easy to get that topic instead of finding them through the lots of research papers.
I just asked the question in terms of that you have used the methodology, to achieve this result.
Yes.
Okay. Now the output which has come, you said, okay, I use this method, and this is the output which has come thereafter. Now, while doing that research, you find certain cons. Okay, of this particular methodology. Okay, this is I'm stuck here. This is something is not achievable, or this is something more works to be done on this. So I'm asking for those areas whether you work on that.
So basically, we stuck to this acoustic signal processing, but using query, we can find different topics as well related to this methodology.
Question was there any cons? You mentioned variability, for example. That is a possible confound that you can have, but you took care of it by having 10 repeated runs. Were there any other possibilities, cons, that means something which method does not work well on, or there are some problems with the method, or something where it can be improved?
So basically, I would say that if we are looking for the topics, and like I can say if there are a lot of things we lose using because it is just taking the abstracts only, and from the abstract it is taking the information and finding the topics related to it. So maybe we will miss the methodology related to other topics. So just we are getting the abstract data, and we are getting the things done. So it is a basic con of physics.
Okay, so do you plan to use it on full-size papers then?
Yes, sir, hopefully. If it works, then we can.
Okay, thank you very much.
Okay, thank you, sir.
The next paper will be presented on physics-informed LSTM, paper ID 4065. Mr. Alex. Sir, I think it is absent. You can mark absent. Okay, okay. Moving forward to the next presentation, research issues and challenges in AI, paper ID 4404.
Okay, good morning to all. My paper title, Research Issues and Challenges in AI-Enabled 6G Network Architecture. This is the outline of the presentations, the objective of this research work, the major technologies in 6G in one place, then the major applications of AI-enabled 6G network, architecture of some of the 6G based network, some development aspects of AI-enabled 6G, AI tools to work in 6G problems, and key research challenges in AI-enabled 6G, and followed by conclusions. So I make my presentations very precise and concrete. Here are a few of the major challenges in the 6G technology identified in some of the domains. If you go in the radio technology, basic things, the important is the reconfigurable antenna. So the MIMO multiple array antenna now will be replaced by or to be enhanced to the reconfigurable intelligent surface antenna. People are working, I think its applications and to be tested in the 6G high frequency platform, and the power, the energy and bit loading, all those things. This is one area. Quantum communications, of course, when you give the ubiquitous communications a network in the 6G, undersea network, terrestrial, non-terrestrial, if you unify all those networks, then probably quantum communications through the satellites may reduce the latency to give a very real-time services. And okay, and then almost zero power IoT, which has been proposed in 6G, bit power per bit, no power will be 1 picojoule as they have given the standard specifications, but still huge and billions of devices will be connected, and this energy of those devices should come from within the devices embedded. So how we can, in this miniature size, embed the energy resource and this renewable energy. That is very, very important for smart industry, wireless sensor networks, and device-to-device communications. Cognitive spectrum, because the spectral efficiency, as has been given, it is very high, but still it is to be tested, and a lot of algorithms and techniques needs to come, and modeling and simulations and test bed implementation should be there. How efficiently we can use the spectrum in cognitive manner or reutilization manner or relay manner. A lot of techniques needs to happen, so a lot of scopes are there in the 6G radio access network. Converged communications and computing. As we are talking about the distributed AI, huge data transfer has to happen to the local AI center, the core network, the server, and from the access. So data transfer has to happen almost instantly. So it's not only the AI processing, the communication should be converged for huge data transfer. So 6G it is envisioned that it is the converged communication and computing system. So new data plane is to be defined and to be tested, and data storage to be managed, and data processing, of course, and data communications. 6 use cases, as already you know, that lot of low latency and massive and broadband communications. So these are few use cases in the 6G, and sensory network to be integrated. You can provide the smell, touch, and visions type of human-centric communications. So the wearable devices, environment, human beings, if it should be connected, and in multi-radio access system, that is very, very important, because many devices will be there very heterogeneous in nature. So how in local level the access nodes can operate different multi-access technology and acquire the data, I think a lot of works. And ubiquitous network, the terrestrial network, non-terrestrial network, undersea network, then drone and aircraft, and then satellites in different level. So their connectivity and intermobility of the users and sustaining the connections and ensuring the delay, the latency, and handover will take place even in the gateway level. So a lot of research has to happen on these AI entities, distributed AI, and the centralized AI, and then digital twin. These are the few things I will discuss in detail in few of the following slides. These are few AI-enabled applications in haptic communications, virtual network, digital twin, edge computing, terahertz band, these utilizations, ubiquitous connectivity, security, high-speed 6G applications, the video streaming, AR, VR, extended reality, low latency communications for different real-time services, autonomous drivers, remote surgery, industrial automation, real-time control system, and IoT application, of course, is very, very important. Holographic communications, so holographic meeting, virtual tourism, education, entertainment, and many more. All those needs a very high-speed data and as if real-time experience. AI ML applications, predictive maintenance, personalized services, and autonomous systems. Many more are there, but I have put a few of the such applications. They are very much expected out of 6G. Now, I will present some of the 6G network architecture, because my research issues highlights in the architecture and network operation sides, instead of going too much in the modulations and communications. So let us see some of the network architecture, and then how do we find the challenges we can take up. See, this is the converged communications and computing architecture. Your lot of extended reality and virtual digital human, and then video and any data communications from the access side. If you deploy, see the core network in the access network in the border, edge computing node. And then it is in core interfaced with some nodes, communication and computing nodes, because these nodes will have responsibility for communications as well as computing. Now, some models may be there, you are taking the centralized cloud computing nodes, or in some of the architecture you can give, deploy the edge computing to make it happen, but controlling should happen from core networks, because AI-enabled control functions will be implemented there. But how for control functions you can migrate from core to the edge computing, so that localized control can also be done, but of course in intimation with the core control functionalities. So basically the control and your user plane and communication and computing will work very closely, and these are all to be developed and to be tested in real time, how it can gives the service with that specification, specifically the throughput and the delay with 1 millisecond. These are few of the control functions I have taken from the net, that all these functionalities in the 6G will be AI enabled, because the 6G itself is giving the self-configured, self-managed and self-monitored network, and native AI will be there. Thus, when we migrate from 5G to 6G, fully AI-enabled network we are considering. So all these functional control functions entities will have the AI training model, and they should work to support the control functions for manage the network or self-healing the network, self-managed network. In the bottom line, we have given that access network, radio access network, the code network, and digital network outside this cellular. And to have this digital twin as proposed for the 6G network will be working somewhat like this. In the core, in the native AI, we will have 3 modules. AI resource will be there, training inference model will be there, and service control. These entire entities basically belonging to the core network control functionalities will be connected with the digital twin, and digital twin based on these parameters will calculate some of the best optimized parameters, but it will be again sending to network state, and then some model, server model should be there. From there, reinforcement learning has to happen. You retune the system and give back to the network. So some of the iterations should happen, and then we can train the network. I think here also people are working, but a lot of things to happen. I'm just highlighting that how the data transfer or the information transfer has to happen from this native AI to digital twin to the network state manager, and from there, which will be centralized, the AI control, and then your model server and information retrieve. So people can work on this. Here, one thing is I want to highlight that this IoT, we are aiming that almost zero power IoT. And you use massive devices to be connected, and power optimizations will be there. If centralized IoT server is there, and we are taking some of the services from the IoT nodes, and then to meet these specifications of 1 picojoule per second, and so all power budget and power optimization techniques in all nodes, including the embedded almost self-harvesting power model in the IoT nodes. Similarly, as we talk about the very human-centric network, environment-centric network, so sensory network will be the standard in the 6G, and if you have some of the real-time services, real-time monitoring, your sensing control functions and sensing data processing functions in the core, and then your AI will compute some of the results in the form of statistics or plan, and some of the suggestions, predictive suggestions can be retrieved from the 6G network by the all home management, environment management, healthcare or weather, transportation, and so on. This is the network that I have built up, that probably unified and integrated network for undersea network, terrestrial and non-terrestrial network at different levels.
Sir, we have 3 minutes to conclude.
Yeah. So I have one more slide. You have airspace, drone, aircraft, LEO, MEO, and GEO, but their intermobility connected in the ground stations, and that is again connected to the unified core network in the 6G, and then external IP networks. So the gateway handover, and in this scenario, in the very mobility, under mobility, the handover will take place in the gateway level. So how do you test, and what is the latency to sustain some of the very highly expected mobile services, maintaining the bit rate with time constant? That is a challenge. I am developments in some of the things I am just skipping. It will be. Now, I just want to highlight that your machine learning model, whatever you will deploy for to do some of, work on some of the research problems in the 6G, this model, this tools itself is to be validated. So, some supervised learning, unsupervised, semi-supervised or reinforcement learning, which kind of model, even in a particular learning model will be best fitting, we need to validate the model validation, the AI tool validation. So, that is also a work. Some of the works I have quoted from the literature review that your in channel predictions, your channel estimations, your beamforming and channel in the access network, if you want to do, probably we need to identify the best and befitting and productive, efficient AI tools to do the model, AI modeling. And this is the probably last slide, some of the research challenges. The AI tool selections, almost I have discussed. Big data transfer and processing, this converged communications and computing. In architecture, it is to be told that the data transfer has to happen very fast and processed. And then complexity in interference mitigations. Those who are working in the access level, it's not only the channel allocations or the spectrum management, it's call admissions control and above the interference level, interference mitigations that can be modelizing, but which model of AI is befitting, that you need to find out. Energy efficiency everywhere, 1 picojoule per bit if you want to satisfy, and if it claims that 6G despite handling such a huge data, still it will consume less energy. Everywhere we optimize, and the power efficient techniques need to embed. So on these aspects, a lot of research can happen. And beamforming and RIS already I have explained. Self-managed networks in the core networks, including digital twin, and the AI enable all the control entities and interworking between these entities and can be modeled and developed and tested. Quantum technology, of course, is in a very unified big networks if you do, or some of the things the quantum communication is required, but quantum security, quantum computing, quantum things can be implemented and tested. Is in non-terrestrial networks, and this already highlighted in the architecture that if it is a unified networking gateway, if you give the mobility from undersea to the terrestrial to non-terrestrial network in different layers, how do you sustain the connectivity and provide the service, and keeping the throughput and the latency in specified, and the green communications has to happen, and AI-based communication by saving energy everywhere. So this is the short presentations. Conclusions is a few points, just all those aspects. Here I can highlight deep learning methods to be, I have told, and edge computing I have told, privacy, security, and policies that needs to be formulated at different level, and quantum and performance for the unified protocol that I have explained, and develop more trusted methods to evaluate the gain, efficiency, and performance of AI-enabled networks. So trusted model we need to come out by testing for test bed and applications, and then probably in 2030 when from 5G to 6G it will be enhanced. Through this, a proper trusted and best technology will come out. So thank you very much. Any question?
There is time for some questions. Please raise your hand. I'll bring the mic to you if you have any questions. Okay, sir. Let me start with one question. This is a wonderful overview of what 6G, what kind of wonderful things 6G might bring in our lives. And there are many technologies which this vision actually depends, especially given the time frame of 2030. So in your opinion, which of these technologies are most likely to fructify and which ones may lag behind? For example, quantum communications you mentioned. In next 6 years, do you expect some other technologies to actually become mature enough to bring this vision forth?
So 6G actually trying to embed all the technologies together. You have seen the distributed AI and your IoT, sensing networks, computing, and to meet the specifications. So specifically in real time, the high data rate service you want to give to say in medical domain, anywhere in the world that using remote control we can do surgery. And quantum technology will be the supplementary technique to implement the 6G specifications. So you have to take that, how you can enhance, implement and make successful the quantum technology in the 6G, such as communication, quantum communications. If terrestrial, interterrestrial and networks will be there, then distance will be more, that how you can mitigate the delay. And then security, of course, yesterday it was a burning issue. So can it provide, because why security is very important in 6G, because you are telling that distributed AI will be there, edge computing you are going to do, converged communication and computing has to happen. Every time huge data transfer will take place. So how do you secure that, how do you ensure the secure data transfer? So you come out with the security mechanism, and that mechanism may be quantum security. So this is the way we have to take that, how these expectations or specifications of the 6G we can implement by putting different technological tools, and one tool is quantum techniques.
Are there any more questions? Okay.
So, good morning. So, sir, distributed AI, like, see, we again, like what we are finding that the distributed AI, if we will go for, right, for different devices. So first question is that, are they, the AI will be of similar patterns or different patterns? Or even if it is the different nature, in that case, again, we are loading the whole network with more computations.
Yeah.
So how we can take care?
I will give this answer in terms of some of the catering services. If you want to give the food services, you have kitchen and hotel, so you can tell your customers that you take the service from me. So you have, I have to access you. Or you can have a distributed catering system. Moment you implement the distributed AI along with the edge computing, and how automatically the complexity increases, because a lot of other control functions and authority access and the authentications required from this core network. But still, locally, it can be processed, and after processing, it can give very fast service to the device level.
Good.
So yes, that's why it is very complex. But how do we implement that? The edge computing along with that. If you can implement that distributed AI, probably in India now, Geo is trying to establish a centralized AI system, and they, through AI, all the users can access that. But for very high-end services, smart services for industry, for medical, smart city and others, when private 6G will be coming, they can customize and they can deploy that what is the latency, what is the data, and what is the service requirement. They can come out with the plan that the way the AI is to be deployed. Right. So that fast data transfer happen and quick service can be given. So this is the planning.
Yeah.
And
So what
when
I
you change
what
the
I
planning, complexity increases.
So what I feel, sir, like still, even if it is the centralized cases, so many things are going to the clouds. But those clouds, those clouds there, like the companies are keeping those server at the different place. So all indirectly they are going like a distributed honor. Not much that much distribution, but the level of distribution is less. Right.
That
But
is,
you are highlighting here the distribution of the AI will maybe a very node level or like
yeah.
local level itself. Okay.
How far in the
Thank you.
hop distance you can decrease? Can I deploy my AI in the e-node B itself?
Correct.
And in and around, so that most of the things can be done, and I am mitigating the latency, because 1 millisecond or 0.1 millisecond delay if you want to do.
But you don't think like that we are going in the reverse directions. For generations, we had gone for higher generations. So we had shifted to the virtualized network, right? Network virtualizations. And now again, we are coming to the like e-node B and then putting the some load there. So it's going that way and then coming back to this
We
side.
will discuss this.
Okay, fine. Thanks a lot.
Your utensil is one, that is a 6G technology.
Yeah.
Now you do lot of virtual network on that.
Correct.
And Henrik told already that virtual slice network. Yesterday also I presented. Your hardware is not changing. Everything you configure end to end, a separate network we are building on the same infrastructures.
Correct.
So it's a lot of planning and separate protocol, stack and control entities required.
Right.
Like we have two such control functions and user functions. Now in control and user functions, if you have slice networks, for each dedicated slice networks, you can have separate control functions.
Correct.
But you are using same 6G technology.
Yeah.
So I think we can discuss
Yeah,
later
thanks.
on.
Thanks
Thank
a
you
lot.
very much.
Moving forward for the next presentation, deep learning based local 5G radio estimation for smart factory environments. Paper ID 8884.
Good morning, everyone. My name is Chang Pyo from NICT Japan. My talk is the deep learning-based local 5G radio estimation for smart factory environment. This is the outline. I'm skip and outline details. I will start in the main items. This is one of the example of the smart factory of the minimal fab. Minimal fab is the concept is to simplify semiconductor manufacturing process, enabling different and flexible semiconductor product developed by the National Institute of the IST in Japan. You can see that the minimal fab is comparative to be a big semiconductor manufacturer. There is quite require big factories, but this is the very small factories for developing semiconductor. You can see that on the bottom figure. This you can see very small office, but this is a manufacturer, the semiconductor manufacturer factor. Actually, this is a really great semiconductor. You can see that this is the one of purpose in Japan. They try to the very small semiconductor manufacturer in order to small scale manufacturing, small quantity of the semiconductor chips, as well as supporting the research as a development and commercializations for the new electronic devices. As you can see that this is very small, the semiconductor manufacturing devices are located on the office. Each office can processing step by step. If you want step, the manufacturers step one processing, and this small chip hand over different devices, and different devices can continue to different processing, and hand by hand, this all process is done, you can find the final semiconductor chips. But the semiconductor operators, they require some necessary of the remote controls over the internet. As well as they want remote monitoring. Now is what is processing is continued. They want to remote controlling of the remote areas. In order to do, they want to use the wireless communications. But the operators, there is not professionals of the wireless communication. This is they have some, there is some challenging issues. One is they want to establish a wireless network easily as well conveniently, but this operator, they don't, there is not non-professional wireless communication. They don't know where the access point is located in the factories, as well as how the wireless, the radio propagation is doing. They don't understand. They want to easily and convenient establish wireless communication in the office. And the second point is that the factory is simply changing the layout of the, because each processing maybe changes month by month. In that, in order to optimize processing, they changing the layout. But every layout changing, they need to changing wireless communication and wireless, the network can be changes. But as I mentioned again, operator is not professional. Every time they don't know how to do, they don't very, very confusing. We try to provide some solution for them. This is why NICT cooperate of the ISD. Then, first thing, I want to provide one solution of the challenging issue, establishing a wireless network easily and conveniently. We are using deep learning-based radio estimation called by radio-less unit. This radio-less unit we have developed in the last year. More detailed information you can find on the paper of IEEE Access. But I'm shortly include on this radio-less unit is to predict receiver signal strength between the transmitter and receiver. This network is based CNN-based deep learning method, as well as this is to combine less unit as well as unit. This is also, we have this network to achieve real-time RSS prediction. You can see that on the right figure, this is the very small the testbed simulations. You can see that on the users only try to draw over the layout, and you can put on the access point. These two information we can provide on the network. The network predict wireless the prediction. You can see that this demonstration tried to explain for the elementary school students. The elementary school also understand what is the wireless communication, because this visualization very easily understand what is happening on the wireless. As well as you can keep on the very small toys you can put on the table and then put on the antenna. The wireless is like this. Then elementary school understand, oh, this is the wireless. This is even though non-professional on the operator can be samely used. This is deep learning network. And second, we are trying to solve the second issue to the how to establishing network, even though the changing the factory layout. In the the original approach is, for example, ray tracing software. In order to estimate radio environment, the software required 2D or 3D modeling of the indoor environment. But modeling of 2D or 3D modeling, this is also very, very complex, very high overhead of the operators. As I mentioned before, that every month can change layout. The operator can redrawing or remodeling of the indoor environment of 2D or 3D modeling. This is very, very high overhead. That's, we are trying to, it is automation to rebuild of the indoor environment. This, in order to that, we create a space database configuration. This database, by using deep learning approach as well as the automatic or semi-automatic approach, we can create databases. This database includes some information of the object on the indoor environment. For example, the location of the wall, or location of the object, location of the some ceiling and bottoms. What other material is the product is used? Something kinds of information is included in the database. This database provides some very easy reconfigure of the model, because if you're changing layout, just update on the database. If you're changing location, just update location on the database. Then, based on this database, this 2D or 3D model is automatically configured. I want to show that the demonstration, but demonstration is a little bit take time, but I'm skip. If you're interested, contact to me. I will show you some simple examples. This is full of approaches. In order to predict some area on the wild environment, first in the real environment, first thing we create 2D or 3D model in order to create databases. Then the automatic on the semi-automatic, we automatically detect on the objects, on, for example, walls or ceiling and the bottom and some other object. Automatically detect, but everything cannot detect. In these cases, we can semi-automatically update on the database by hand. Then you can see that database inside of database include very some useful information of the location of the object, the types of the materials, and something like that we include on the database. If we create database, we automatically create it on the 2D or 3D model on the can be easily obtained. Based on this 2D or 3D object, this information put on the deep learning network. Deep learning network is automatically predict wireless information and visualization, and like this. And then on the minimal part, I can use this full procedure on the minimal part cases. And also we purified how much matching on the real measurement or the prediction. In the real measurement, we can try to, by using some robot, we can exactly the radio receive signal on the the exit position. The right figure shows some receive signal strength on the different position of the G node B. G node B is the base station. In these cases, we can see that on the results. This is the prediction by using our the deep learning approaches. The bottom figure, how much difference between a real measurement and the prediction. You can similarly you can 2 or 3 dB difference, and the real measurement and the predictions. This is very high accuracy you can provide. And this result and the manufacturer operator very happy. It is in different places can be used our approaches. Okay, finally we are conclude. This paper explored the advancement of smart factory. ICT and the wireless communications. One of the example on the mineral path. And the learning approaches is powerful technique can be used to predict behavioral wireless signals in the indoor environment. To improve the accuracy of the predictions, we use the semi-automatic and the built-in database of the indoor building information, as well as this database can provide very flexible approaches to creating the 2D or 3D modeling. And by combining the power of the deep learning algorithm as well as to the databases, we provide the highly accurate prediction of the wireless signal of the indoor environment. Thank you so much. My presentation is done. Do you have any questions?
Any questions from the audience?
Okay, this is very interesting presentation you have given. One question is coming to mind because the operator who is doing the, who has the factory setup, right? So he's manufacturing the thing, right? And your methodology is giving the, in terms of how you're going to reorientate, the factory setup to give the output, correct?
Yes.
So my question is this, if the certain things into production, right? And you have given the possibilities dynamically to improve that. So how much productions, it has to start, and and then your data will come. What is the timing difference, and how much you can spend, because the overhead cost, the way you rightly said, there is a huge overhead cost of reorientations. So what is the latency of this data, and when is a ticking point, that he has to reorient that. So have you worked on those lines and some data which you can share on this? I think you clear my question, right?
I'm sorry, I don't catch your exact point, but what is the, I'm sorry again, could you say a little bit shortly your questions?
Okay. The question is basically like, the certain thing which is in production, okay, and you're providing the live data, okay, this is, at this point, this is something you have to reorient your factory setup. So what is the, the factor or the, this is the ticking points you have created, okay, this point, you have to stop this and you reorient it in this particular, way to do the production. So anything, any guidelines for those?
Yeah, no, this is the, okay, this is the, my point is that we provide some deep learning approaches to somewhere. They, in one thing, the factory, some non-wireless non-expert, they want to understand what is wireless in our actual field. In order to that, we support to do understanding wireless like this. This is collaborate the other side. Our is the wireless the expert, but the other side is not. Then we are collaborate to each other. We provide more growing up the synergies. This is our point. We are not trying to some benefit for them. For we are not a company or an institute. That is why we are trying to do. But this is my answer. Not right question, right answer for your question. But my understanding like this. I'm sorry for that. This. Yeah.
So now there are two domains. My question basically is, as an architect who's building a house for me, and how does your wireless communication fit in there? If I want a Wi-Fi, latest Wi-Fi there.
Yes, right. Yeah, yes, yeah. Oh, yeah, yeah. I'm trying to do, but the offline, you can continue for that.
I have a quick question for you, sir. Just one quick question. You mentioned this deep learning model, and you had used ResNet followed by a unit. Was ResNet part of one of the arms of unit? Was it used separately? I was just curious about the architecture that you used.
Yeah, basically we are using ResNet and the unit, but we are reconfiguring on the network and the conventional approaches. But this is our original point is not a, we are, how to say, it is the combining on the indoor environment as well. Before last year, they didn't any the paper for that for indoor information. Then we are originally we creating data on the indoor information by use in order to use to the our networks. This is our approaches.
Very nice approach, sir. See, I have two questions regarding this one. First thing is that the space database you are including, especially for indoor environment, right? Indoor environments. So what I'm finding like the indoor environments are almost similar, most of the cases. So do we find like so much significant difference in like if we add the this space database, database space in between, and then go for modeling and then like, so one confusion arised for the result side also, right? What was the comparison? Can you show that result? Next. Yeah, here. So these are like two different scenario or what?
No. This is comparison on the prediction and the real estimations.
Okay.
We compare to two things: real estimation result, the prediction result.
Okay, predicted and okay, estimation results. Okay.
Yeah.
So what we were looking like, if we are not including this model, have you compared any results? Then how much difference you are observing there?
Yeah. Yes. I'm not. This is more. We already they published the paper for radio rest unit on their papers.
Okay.
This network details on the information you can please find on the paper.
Okay.
And this
so what is the typical value
in
terms of typical value? Like how much difference you had observed there, right?
Yeah, you can find them.
Okay. That's fine. And like is the eNode B locations will also matters, right?
Yeah,
Means if you are changing the internal environment, right?
Yes.
So the eNode B locations as you are giving, then their model may be affecting different way.
Yes, right. Yeah.
Okay. So thanks a lot.
There is one question there.
Thanks for the good presentation. And I have two very stupid questions. The first question is that, well, if we want to know, for example, if I use Wi-Fi to connect all your equipment of semiconductor, and if we want to find the signal quality at somewhere, well, actually, we can directly deploy a UE to measure the signal quality. And if we find out that, well, for example, at some place, and the signal quality is not good enough, we'll just deploy one more Wi-Fi AP here. So what would be the reason to use the deep learning to perform such kind of a prediction? Because if you use the deep learning, the cost is really high because you need to prepare a data set, you need to measure the signal quality at everywhere. So what is the real benefit of using the deep learning to perform the signal propagation prediction? That's the first question. And the second question is regarding the model of the deep learning, because you use the ResNet, right? Because, however, if my understanding is correct, ResNet is used for the image recognition. So the feature designed for the ResNet is majorly targeted in the image feature. However, if you want to predict the radio propagation, the feature may not be similar to the image object. Yeah, so what will be your reason to use the ResNet as your model? Yeah.
Yeah, and for the first question, the deep learning approach is, what is the benefit of deep learning approach for wireless estimation? This is, I mentioned that the first thing, this is that, in the not wire is some real actual field, like some manufacturer factory, some constructor. The operator, the users, they don't understand wireless, but they want to require, I want to wireless somewhere, or IoT devices by using Wi-Fi, any other the wireless communications, but they don't understand wireless. In order to that, I mentioned deep learning approaches provide very simple and quick solution for wireless understanding. This is one of big advantages why you are using deep learning approaches for that. And second question, less unit, but unit is using on the pictures. Yeah, your question is right. We are also how to say, pre-processing by using the images. But I don't describe details. You can find the following, the paper, the very details processing. Simply, you are using also images by using ray trace, created by ray trace software. Basically, ray trace results, by using ray trace results, produced by the images, we can the running for the predictions on our network.
Okay, thank you very much, sir. It was a wonderful talk. And we move on to the next talk now.
Thank you. Thank you very much.
I thank you all for being a part of technical session 11. And I would now request Dr. Ashok Kumar, sir. Dr.
There was
Satviri.
one talk, a second talk, the speaker was not here. Can you announce the name again so that if he is present, we can go on with that? The second paper number?
Dr. Indu Bharadwaj.
This was in Muhammad S. Khan's group, Dr. Khan's group.
Mohammad S. Khan will be not here.
Okay, all right.
So we might be shifting his presentation to another session.
Okay, okay, fine.
So I would now request Dr. Ashok Kumar, Dr. Satyavir Singh, and to felicitate our external session chair, Mr. Vivek. So please come in the dais.
So, good morning, everyone. Please join us for a network connect outside the auditorium, and we'll be rejoining back at 11 for the keynote address. Thank you.
नहीं ओके
You are Dr. Bipin? Hi, good morning, Dr. Vasu. So, just waiting for... So, ladies and gentlemen, it's my pleasure to introduce Professor Biplab Sikdar, a distinguished academician in the field of electrical and computer engineering. Currently, he is professor and head of Department of Electrical and Computer Engineering at National University of Singapore. In addition, he leads the highly successful Cisco NUS Corporate Research Laboratory. Professor Biplab is a recipient of numerous prestigious awards, including the NSF Career Award, the Tenchin Tuan Fellowship, and having various fellowships from Japan Society for the promotion of Science and Research Council of Norway. His research focuses on IoT and cyber physical systems, network security and performance evaluations. Dr. Sikdar is a recognized leader in his field. Please join me in welcoming Professor Biplab Sikdar. I request Dr. Pratima, Head of Department Electrical and Electronics and Communication Engineering, to please felicitate Dr. Biplab.
Okay, so good morning, everyone, and thank you very much for inviting me here, especially Swadesh and Nili. Thanks for the invitation, and I'm very happy to be here. So today I'm going to talk about security challenges for AI-driven 6G networks. So the way I kind of thought about this was mainly from the student's perspective, right? It's probably not for the more established researchers in the audience, but students who are trying to get a feel for what, some of the things that might be important in 6G context. And specifically, we're looking at, when AI comes into 6G, what are some of the things that we may have to worry about? So it's more of an overview talk rather than something very deep and technical, right? So that's the idea. So this is what we'll do. We'll talk a little bit about how 6G and AI might be intertwined together as the standards are being developed. Then I'll talk a little bit about security concerns with 6G, with AI and 6G. And then maybe a little bit towards the end, I'll talk about what are some of the potential solutions that may be out there. All right, so 5G is being rolled out in many places, including India, I guess. And while the process is ongoing, people, including academia, industry, we are talking about 6G, right? And the vision is always the same when you go to the next generation. The vision is always about improved data rates, reduced latency, and so on. If you ask many people about 5G, some will say it's a success, some may have a differing opinion. But in terms of, when you think about use cases for 6G, it's kind of, to me, it's, old wine in new bottle kind of thing. Things which we envisioned would be happening already in 5G but haven't taken off. Probably they will hopefully see the day of light in 6G and so on. But one thing that people do agree on when we talk about 6G is that the confluence of artificial intelligence and into the communication network. And there are some reasons why we may want to adopt AI for communication networks. Of course, we are more familiar with things like language processing, image generation, and so on, like ChatGPT or whatever. But there are some things for which AI might be very well suited in the context of wireless networks. So one of them is, there are a lot of non-linearities in wireless networks. So decision boundaries may not be very, very well defined, right? And AI in particular is very good at learning these non-linearities. We don't know how they learn it maybe, but they can learn, right? So for those kinds of things, it might be quite useful. then, you know, I'm a classical engineer in the sense, when we were students, we did many, many math courses. And when we think about engineering, we think in terms of, oh, I need to be able to model it, I need to be able to characterize the process, and then find the optimal solution. But sometimes finding those optimal solutions may be difficult or time-consuming or computationally complex. Probably AI, maybe not in the training phase, but in the inference phase, maybe it can give us results much more quickly, right? And one of the things that we think would happen in the next generation of, in the 6 years, what we called AI native, right? Which means that the boxes and the equipment that we'll be using in 6G would probably come with AI built in various kinds of functionalities. And that's one aspect of it. And then the other aspect is how we can use AI to design the algorithms, the air interfaces, and so on. So another viewpoint of looking at it is if you look at the various layers, so these are, you know, just like your OSI, ISO layers that we have for the network protocol stack. So this particular figure right here is more optimized, let's say for, not optimized, but more representative of what happens in a cellular network. And we expect that AI would play a role in handling the operations of each one of these layers. All right. And the last vision, and you know, if you go to any of these conferences or any other places, most of the keynotes will talk about is, you know, how sensing and communications will be integrated in the 6G world. So essentially, we turn the network into a sixth sense. So the network helps us understand what's going on in the environment around us, not necessarily related to communications, but in general, how the users are behaving, where things are going, and so on. And maybe that can help us to optimize our work and living environment. So that's the other goal. So this is sort of the other view of where AI and 6G will probably come together. And this is in the way of integrating the physical world with the digital world. When we talk about digital twins, that may be more in the context of industrial systems, but you know, you can also think of that in the personal context where the wireless network is sensing everything around you, and then we are using the data that's coming in to sort of optimize your living conditions. So that was a very high-level overview, maybe where AI comes in, and now let's look at some specific wireless comms kind of problems where AI may be useful. There's a whole list here. Maybe we don't need to go through each one of them one by one, but let's take a few, right? So the first one is channel estimation and equalization. So when we have a wireless network, we want to estimate what the channel is doing to our signal with the hope that then we can compensate for it, right? So equalization is basically reversing whatever the channel is doing to your signals. So we have traditional signal processing ways of estimating what's happening with the channel. But when AI comes in, hopefully the idea is that maybe we can learn about what's happening, and then we can forecast what's going to happen in the near future, and then we do our equalization accordingly. And then there are a whole list of things, right? And here are some possible use cases of AI. Just to take an example, so let's say you have a highly mobile user here. Maybe you can use some AI techniques to predict their movement. You can predict their channel conditions and then allocate resources accordingly or adjust your link parameters accordingly. Another example might be, let's say, scheduling and resource management. So if you know exactly what kind of users are, so for example, there's an individual here and maybe a bus here, so of course you can allocate a larger amount of resources here, and then you can steer and so on. So there are many different use cases. Another simple example might be, you know, the use of large language models for 6G environments. So I think this is still a very nascent area. To me, it's not clear how LLMs are playing in, but a lot of people are working on LLMs. And the reason I have this here is because I will come back to this figure in just a bit, right? So as with any other model or any other AI, what you'll do is you get your data, you train using your data set, you come and in the case of LLMs, you have an encoder that you come up with, and then you can use it in the case of, let's say, a cellular network to classify something, right? And let's say you have an LLM-based AI model that you're using in your cellular network. Now, I can generate a very large model using data from everywhere. But if I deploy that in a cellular network here, let's say in Noida, I guess this is Noida, right? Yeah. The environment here, right? If you go outside, the way the channels look like, the way the environment is, the buildings, the foliage and the trees, it's very different from where I come from in Singapore. So our landscape is very different. So you may have a model that works well here, but if I just directly take that model and apply it in a Singapore environment, maybe it doesn't work so well, right? So you may want to update certain things in your model. And how you would do it is you will take your local data and then you'll update certain things in your model, right? And you can have different levels of customization. Here I'm just updating the classifier, but I can also update the encodings and the data itself. Of course, it's more computationally intensive, but then we can do it, right? And this is something I'll come back later on when I talk about security and privacy. And so now slowly moving over to the security issues in 6G networks. So this is a slide that shows you various security issues in 5G networks, not 6G. But many of the threats will still remain in 6G. So for example, you have a wireless link between the user equipment and the base station. So this is the wireless interface. Anytime you have a wireless interface, no matter what you do, you will be susceptible for eavesdroppers. People will try to listen on to your conversations, right? Of course, you can encrypt and other things, but people will do. If you have edge devices, just like you have in 5G, and then you have edge devices in 6G, you may worry about somebody launching a denial of service on them, let's say. So this threat landscape will also still be there in the case of 6G. And then there are this whole list, right? And then again, with 6G, if we think that there will be a large number of users, different kind of operators, so then the trust model also needs to evolve. And it's not always very straightforward or a trivial matter to enhance your trust landscape when the number of participants increases. So these things are still kind of in the traditional domain. We have been dealing with it in every generation. What is probably a little bit newer is, you know, I was just saying, oh, AI will play a big role in 6G. But that doesn't come for free either, right? So even with AI, if you're integrating it, you have to think about, okay, what would be the other side of the implications? It may lead to better network performance, but can it also have some detrimental effects? So this is our regular machine learning pipeline. For example, you start with collecting data from the physical world. You have your training data. Then you learn something from it. So you have your training model ready. And then, so this is the training phase. And then you would move on to the actual operational stage or the inference phase, right? This is where you use your model. So everything is good if everybody in the world is nice and honest. But then you can also have different kinds of attacks. So you're using your training data here to train your model. Where did you get the data from? Did you download it from the web? Did you buy it from somebody? Are you sure that the data is genuine in the sense that there's nothing malicious in the data? Let's say you bought some labeled data from somewhere. Are you sure all the labels are correct? Of course, there can be natural mistakes in the labeling, right? But what if somebody intentionally mislabeled your data? Then whatever you learn from the data will be wrong, right? And then let's say you have deployed your AI model now. One example could be maybe you have deployed your AI model to detect network intrusion, right, or attacks in your network. So the way that is basically you have deployed a classifier that takes in data and classifies attack, non-attack. Is it possible for me to evade your model? Can I somehow create my data in such a way that it will evade your model? So these are the kind of things we need to worry about. So here are some examples of potential security attacks, specifically in the case of 6G, but it's fairly general. So the first category might be poisoning attacks, where somebody intentionally puts in malicious data for your machine learning models, right? So data poisoning. The other things could be that, many of our AI models are learning continuously. So if your model is learning continuously, a man in the middle or a packet drop attack could also impact your thing. So maybe let me motivate it to you using a more of a pictorial thing, right? So let's say these are two classes that I have in my data, the circles and the crosses. In the natural world, maybe this is the decision boundary between them, their separation. Okay, now I am malicious, I'm a bad guy, and what I want is, I want this, so maybe there's another circle here, right? I want you to make a mistake. I want you to classify this circle as a cross. So what I will do is then, I will insert a Poisson data sample in your training data set. I will insert a false sample here, and I will label it as a cross. If I label this as a cross, when you're learning, your machine will learn this as the decision boundary. So when a real sample, this circle thing here appears later on, oops, you will misclassify it as a. This is a very simple example of how I can poison the data and make your model make a mistake, right? There are algorithmic poisoning attacks. So if you follow the research in wireless communications, you'll see a lot of work on federated learning, right? And the idea about federated learning is I don't send all the data to a central place and learn from that, but individual users will build their own mini models, and then maybe I'll share that model parameters, and somebody will combine all those model parameters to come up with the big model, right? So what if I am malicious? I don't give you the correct model parameters. I give you manipulated weights of my local model, and then when you update your global model based on these manipulated values, of course you will make a mistake, right? So this is one example of a backdoor attack or a model poisoning. Then there are also adversarial attacks, and this is the one that I was talking earlier about, that when I introduce some noise in the data maybe, or some other characteristics in the data, as a result of which your classifier or your AI model makes a mistake. So just as an example, maybe pictorially it's a little bit easier to understand. So let's say you have a classifier that classifies what kind of animal it is, right? So you give a picture, and the classifier will say what animal it is. So if you take a look at this, all of us will say it's a pig, and most classifiers now will also say it's a pig. But if I add a white noise like this, not very high amplitude, right? I multiply it with a very, very small number. So to the human eye, this still looks like a pig, right? So I have taken this white noise and I have added it here. So now I've superimposed. To the human eye, it still looks like a pig, but your classifier now says it's an airline. So this is basically an adversarial attack on your model. And another example of that is, so let me clear the thing. Another example of that, there's a gun there. So it classifies the gun correctly. Now if I tilt it by a certain degree, now it classifies it as something else. Now these are pictures that I put in, so we have a better understanding. But imagine we can do this for wireless communications or any other kind of data also. And these attacks can be you can classify them as error generic or error specific, or poisoning attacks and evasion attacks. So poisoning attacks, which are error generic, is I just introduce some data to lead you to make a mistake. I don't care what mistake you make, as long as you make a mistake, I'm happy, right? So that's error generic. Or I could also say very, very error specific, like I want to modify your decision boundary in a certain way, right? Evasion attacks, for example, in many places we have, biometrics for entry. Right? Today when I came in, they took a picture and everything, so they compare my picture with the one in their files. So one example there could be that I modify my image so I look like somebody else to gain access to the system. That would be an error generic. Or I could say, oh no, I know somebody, some famous person, Amitabh Bachchan has access to this building. If he shows his face, I will make my face to resemble Amitabh Bachchan, and then I'll get access. So this would be an error-specific evasion attack. The other kind of attacks which we may want to worry about is privacy and fairness, especially in the context of, let's say, your wireless or cellular networks. The way you learn is based on your users' data. So right now I'm on Airtel, so Airtel can collect all the data about me. What if they leak this data someday? And depending upon which country you're in, there are different kinds of laws that govern whether users' data can be leaked or not. The other thing can be that you have developed your AI model. You have trained a model. That's your intellectual property. What if somebody steals that model, right? So that will be an inversion attack. So and then you can also classify these attacks based on the capabilities of your adversary. If your adversary doesn't know anything about the internal things about your model, that's a black box. And the other extreme, which is rare, is the adversary knows everything about how your model is, how many layers you have, how many neurons in your model, and so on. So that will be a white box. Most real-life cases will be something in the middle as a gray box attack. So now if you have attacks, then people will also work on defensive strategies. So we have these attacks that we talked about earlier. And now we also can do defensive techniques to protect against these attacks. So for example, if you say, oh, somebody may poison the data, and as a result, I'll learn wrong things. So why don't you make your algorithm more robust, right? So there's the people who develop more robust techniques for protecting algorithms and so on. So now to kind of wrap up everything, I will talk about one specific thing, which is about machine unlearning. And this comes back to our privacy issues and the thing that I was showing you earlier about large language models maybe. Yeah, here. So here I said, okay, we have a large language model maybe, and then I sell it to different telcos. But the telco in let's say Noida will have a very different operating parameters or environmental conditions compared to the one in Singapore. So if you want to optimize your local conditions, you need to learn based on local parameters or how your local users behave. So you will train on your local users' data. So if I'm in Singapore, my telco will learn, the data will be based on me, right? And then one day what I could say is, okay, fine, you have used my data so far, but now I don't give you any more permission to use my data, right? So in the European Union, there's something called GDPR, General Data Protection Regulation or something like that. And in GDPR, we can say, oh, I don't give you permission to use my data anymore. So please forget my data. So what are you going to do? So the basic case that you can do is you have to unlearn your model. So you have to retrain the whole model excluding my data. You could do that, but that's very, very expensive, right? So how can we do machine unlearning? If somebody says, don't use my data anymore, or you find that there's a problem with some part of the data, then you have to rebuild your model excluding that particular data. But you want it to be as efficient as possible, right? So that's where unlearning comes in. So there are two approaches. One is the exact approach where you say, okay, I'm going to take out the data and redo the whole process, retrain my whole model from scratch. This is the best you can do, right? If you're thinking about benchmarking, this is the best, but this is also most computationally intensive. So the approximate unlearning processes try to come up with something in between. So they may not forget everything, but at least they are computationally much more feasible, right? And so this is some work that my students did, and I'm just presenting here. So we're talking about large language models. The other one is a diffusion model, right? So diffusion models are pretty good at generating images and data and so on. And what a diffusion model basically does is, so let's say you want to generate pictures of something. So the way we train these models is you start off with an image and you go in multiple steps. So there's a forward process and a reverse process. In the forward process, in each step, you add some noise to the picture. You keep adding noise to the picture maybe 10 times, 100 times, 1,000 times, so that as you keep adding noise again and again and again, after some time, it will become like a white noise, like the one that I had here, right? So if I take this image of the pig and I keep adding noise like this, if I add 1,000 times this noise, ultimately, it will not look like this. The whole thing will look like this, right? So in the end, I end up with a Gaussian noise like this, white noise. But now you tell me, hey, recreate the picture, recreate another pig's picture. So now I go into the reverse mode. And what I will do is I will successively subtract the noise from here. But I cannot just anyhow keep subtracting noise. The way I have to subtract the noise, I have to learn how to subtract the noise so that ultimately I will create another picture of a pig. Right? So that's where the whole learning process comes in. So this is the forward step, where in each step I'm adding some noise. And in the reverse process, I subtract properly chosen noise. So in the end, I will get another ping. And the way I learn it is, again, just with any other learning model, there's some loss function that compares the original picture with what you're generating, and then you want to minimize that loss, right? So that's about it. So now coming to the sample unlearning thing. So let's say I have created this diffusion model based on a large data set of users' wireless data, and somebody says, please forget me, right? So then what we got to do is we follow, so our algorithm follows a similar process, but in the reverse step, in addition to subtracting what we think is the correct noise, if there are certain images I'm supposed to forget, for those, I add some additional appropriately chosen Gaussian noise. So the trick, so it seems simple, but the trick is to say, how do we actually choose this? Again, the way we want to choose this is you have to create an appropriate loss function where we take into account the fact that now we have an additional noise parameter which will help us to forget. But then for the rest of the model, I still want to be able to create my original data like that. And this is sort of like, so now I'm looking at the clock, so I'm moving a bit quicker here. So this is sort of my unlearning model. So if it's a piece of data that I'm supposed to forget, I use a different loss model for it. And if it is something I am allowed to remember, I use a different loss model for it. And then the parameters are chosen appropriately. So this is a bigger, more detailed algorithm. Of course, just to show that there is an algorithm, we're not going to go beyond that. And then again, when we are trying to evaluate this, we also need to worry about how you come up with the evaluation framework. Especially with AI-related things, you can do many, many things and create whatever kind of results you want. But if you want to be fair, you want to make sure that you are actually evaluating it properly. So then we have an evaluation framework also for that. So without getting into the actual details, the idea is that you have your basic baseline model. You see what is the data that's being created, and you see how much duplicate data that baseline model generates. Then you have your unlearned model. You run that. You create some synthetic samples from that, and you compare the synthetic samples with the samples from the original model, and then you must compare how close they are. So there are different kinds of closeness metrics that you can use, and then that will tell you whether you're forgetting the original data or not. So this is sort of the evaluation framework, and this is what our results look like. So this is the baseline. This is basically you want to forget somebody, you remove their data, relearn the whole model. And this is sort of ours. Of course, the performance may not be as good because this is sort of the optimal solution, but the number of operations we need to do is much, much lower. So computationally, we do much better. So anyway, so sort of coming down towards the conclusion. So if you think about what else probably we could be working on or possible future directions in the next 5 years. So again, I think in the context of wireless networks, active or continuous learning is going to play a very important role because you just cannot always assume that whatever I've learned in the past will always work in any environment that I have. Environments can be very dynamic. There are many environments in forests and battlefields you have not seen before, so you have to continuously learn and so on. LLMs, I'm on the fence personally, but a lot of people seem to believe that LLMs have a future for wireless networks, so maybe something there. Model and user privacy, that's never going to go away. It's a security problem, and I personally believe that as long as humans are there, security problems will persist. We will come up with a defense, and the adversary will figure out how to break that. Right? So this will always keep on going. And so when I say latency and bandwidth issues, they're not talking about, increase the throughput, reduce the delay. When you're using AI, now you're increasing the amount of data that you're using. This is more of, in a traditional way, I would think of as control traffic. Right? the data that I'm using for learning is not necessarily useful data that the users are transferring. So if I'm very, very reliant on these AI models and I'm using a lot of data to learn, then I'm introducing overheads in terms of bandwidth and latency. So how do we minimize that? And finally, responsible and explainable AI. So I may be using this model here, but can I really be sure that it's fair and it's not biased and all those things? Can I actually explain? So previously in the wireless world, if you had an algorithm, you could explain exactly why certain decisions are being made. But with AI, you may not be, right? But it's always good to be able to explain that. So that sort of brings me to the conclusion of my talk. So the key message I want to deliver is that AI will definitely play a key role in the next generation networks. But AI comes with its own set of security challenges that we need to be worried about. So there's significant room for potential work there for researchers and young students looking for problems in the area. So thank you very much for your attention. Oh, so yeah, there's a question.
Yeah, so in the example which you showed, you had added white noise of the level of 0.005, right? With the picture of a pig.
Oh, मैंने निकाल दिया.
Yeah, so that's it will 26 because it didn't have power. Yeah. So
you're
anyway,
talking
it's
about
okay.
the unlearning model?
Yeah, so the thing is that that's like if you translate to SNR, it is 26 dB. So if your classifier has difficulty with 26 dB SNR, then what kind of classifier is it? Because normal data communication you can handle with much lower in an EWN channel.
That's right. So again, so one of the things about this evaluation thing would, of course, how much I forget, but I cannot ignore the utility of the data. If after I add this noise, I forgot your data and everything, but if it impacts the utility, ultimately what is the data going to be used for? If the utility is lost, then there's no point doing any of this. So evaluation metrics, so this data was done for images. So with image, it's easier to say, oh, this looks close enough to a pig or whatever, so it's good enough. But I agree completely with you that if it is wireless and we are doing these things there, then we definitely have to worry about utility. If traditional things are more robust to these noises, then we should definitely use traditional methods, definitely.
Thank you, Biplab. Good talk. I have two maybe suggestions, then the questions.
Yeah.
First is that when you collected the data, in AI world there's a pruning. You don't take the data as it comes because there's a
That's right.
volume might be too high, and you might want to really prune the data,
Yes.
which is more matching your some sort of the metric you're going to put through your data.
Yes.
So why don't you do that? Secondly, question I have, there's a thing called supervised learning. So supervised learning will also help you to do the malicious attack, like man in the loop or something like that, which you can see, because those are, as Ranjan was saying, those are outliers, right? And outliers, if your classifier is not doing it properly, then that classifier is not very good. So if you do supervised learning, then those classifier can work much better. So I will suggest that you should do pruning, you should do supervised learning. That will make your data much more robust, and it will not affect your your AI algorithms to get attacked by some spurious or some invaders. Okay? Thank you.
I agree. I think if we can, let's say, let's talk about the last one, right? You talk about supervised learning. So if I have very good labels that this is this, if my ground truth is very well established in supervised, we will not have any problems. I think that this problem comes when I source my data from somewhere and they have labeled the data for me. And maybe it's such a large volume of data, And I don't have the expertise to go and ensure all the labels are correct or not. But you're right that if the data is very well labeled and there's nothing malicious there, we will be okay. Yeah.
Thank you.
Thank you. There is a question. In
I had another.
Oh.
Another quick question.
Yeah.
Actually, it's not 26 dB. It's more than that.
Okay.
Yeah, because 100.
He's a mathematician.
Yeah, 100 squared.
Yeah.
Okay. Another question is that you said about subtracting noise. You cannot subtract white noise. You just increase the power spectral density. Even if you do a subtraction.
So
operation.
the idea is that, so in the ideal world, right? So if I had an image of this, and I was adding noise, and ultimately it became a white noise kind of pattern, right? But I want to get back to the original image or something like. So I cannot I subtract noise, but not any arbitrarily chosen noise. Ideally, I should subtract the same sequence of noise that was added. Then I will get back the original image, right?
That's okay. That's a correlated. That's 100% correlation.
Yeah, that's 100% correlation.
Yeah,
that's the
but that you can subtract.
High correlation.
Yeah, that you can subtract.
So I don't want the exact same image, but similar image, which will be convincing that it is, right? So how do I know how you had added that noise? And I need to learn that and subtract that accordingly.
Yeah, got it.
Yeah, I think there's a question.
Okay.
Oh, go ahead.
Thanks for the presentation. I think that this talk is really in time and advanced. So I have a few questions regarding unlearning. First is that, well, suppose that you have a continental model, and this continental model is trained from multiple data sets. And suppose that there are some data sets, for example, it's an event, there are some malicious issues. And when you do unlearning, you just want to deploy the part of the model that are used from this malicious data set. You don't want to destroy all the model because most of the model may be normal. Is your diffusion model data set specific? It means that you can exactly destroy the how the model come from the data set which are malicious. This is the first question. And the second question is regarding the code of the unlearning. Because I don't know, someone said if you want to unlearn the model, the code may be similar to train the original model. So what would be the code of the unlearning?
So let me try to answer that here. Yeah, so maybe I'll answer in the reverse order. So your second question was about the cost of unlearning because it may be just as expensive, right? So that's the exact approach. If I, let's say, take away your data and relearn the whole thing, then it's roughly the same amount of effort as the original one. So ideally, I don't want to do that. So I want to have these approximate unlearning methods. And even in these approximate unlearning methods, so this is sort of related to your first question, that how do I save on my effort? There are some data which is good. I don't want to forget those. I only want to take out the effect of the data that I don't want. So there are many different things that people propose, like sharding and slicing. So you train many different models with small pieces of the data. So this is your whole data. You take this, train a model, take this, train a model, take this, train a model, and then you combine. Later on, somebody says, hey, this part of the data has a problem. So I only learn this part of the model again. The remaining models, they can stay. So these are some tricks people use to sort of reduce the cost of computational burden of unlearning, and also to don't have to redo the whole process again. But this is, I think, the biggest challenge here, that how do I ensure that I've forgotten, but at a reasonable computational price? That's really the trick. Yeah. Thanks. very much.
Thank you so much, sir, for your valuable insights. It is my honor to introduce Dr. Suan Zung Soo, a distinguished professor and director of Graduate Institute of Communication Engineering at National Taiwan University. His illustrious career spans both academia and industry, with key roles at NTU, Princeton University, and Bell Labs, where he made groundbreaking contributions to wireless communications. His research focuses on signal processing, wireless communication networks, and playing a pivotal role in advancing 5G and beyond networks. Among his many accolades, Dr. Soo has been recognized for his excellence in research with many awards. Please welcome Dr. Suan Zung Soo. I request Dr. Sibaram Khara and Dr. Parmanand sir to please felicitate Dr. Suan Zung Soo. Thank you, sir. Thank you, sir.
Okay. Thank you all for having me here. It's an honor and a pleasure. And of course, thank you, Lini, for inviting me. And thank you, Vice Chancellor Carlos, for tolerance. Because before I was getting here, I had some visa issue, not with India, but with other countries, because I'm also going to go to South Africa for GlobeCon. So anyway, so I'm very happy that I'm finally here. And my name is Xuan Zong Soo, and people usually just call me by my initials, HJ. And I'm with the National Taiwan University with a Department of Electrical Engineering, as well as Graduate Institute of Communication Engineering. And so for this slide, since we are in this building, which I was told it's a library as well as the auditorium. And in this picture, there's on the lower right-hand corner, that's a library for my school, National Taiwan University. And it's also in the center of the school, and it's also very nice. So if you get a chance, then you're welcome to visit. And I was also told that there are some students from this school who went to Taiwan to get their PhD. So yeah, it's very nice. And I hope we can have this, continue to have this kind of academic exchange. All right, so today I'm going to talk about NOMA. I think many of you must be very familiar with this topic. So maybe, it should not be me who just put a few additional words. But what I was experiencing was that when I submit paper, and also when I'm being an editor, I was handling papers. Recently, I think there are a lot of misunderstanding. So especially some of the reviewers, I don't know, maybe they're young, like, they're not like me, who is the old fart in this communication area. So they tend to think NORMA is a specific thing from maybe 2013, and for a particular standard contribution or a standard or particular paper. And but we all know that this, from the history of communication and information theory, everything that is capacity achieving, most of them are non-orthogonal, right? So basically, that's a long history. We should not forget the past. And in fact, nowadays, as I came to preparing this set of slides, I kind of found that this is an interesting topic, and it will exist everywhere, because nowadays we long for bandwidth, right? We long for higher data rate, and we long for more devices coexisting in a certain network. So everything now will become non-orthogonal. And that's why if we can understand this better, and we will have a better future in the design of the coming 6G. Okay, and before I go further, this is a collaboration with many of my students who are now, most of them are now with a company and earning much more salary than me. Yeah, so, but anyway, I think they have done a very good job. All right, so in the recent years, this term NORMA actually was coined in the paper which I have given at the bottom, and this is from NTT Docomo. And I think for people who are working on standards, 3GPP, I think the first thing about NORMA, they would say is this paper, right? And I think the idea is quite simple. For example, we have, oops, okay, anyway. We have a base station here, right? And if, say, there are two users, one is closer to the base station, the other one is farther away from the base station, then it's possible to let both of them use the same time and bandwidth. So you will be transmitting to them at the same time in the same bandwidth. And in this case, because for the first user, the channel is better, so the base station does not need to send too much power to it. While for the second user, it's far away, so the base station will need to send larger power. And when we superpose them together, they call it as a power domain NORMA because you stack the power together, right? And for the first user, because the signal for the second user is much stronger, so we can decode first. And then at the first user, you can do the successive interference cancellation. And so this is how the, say, additional capacity is achieved. Okay, so this is, I specifically put this one is just to show that, okay, this is a recent memory of NORMA. And after that, of course, people started talking about, okay, so this is one way to go, and what are the other ways that we can do? So we talk about power domain NORMA, and then actually even before this 2013 paper, before that, many people already try to, say, communicate with overlapping signals or non-orthogonal signals. And so power domain NORMA is intended for increasing the spectral efficiency. While there are other things, we can also stack all the users together, but then we can differentiate them by using some specific channel codes. And they actually were very ancient examples. For example, CDMA. People, different devices are using different codes, and we can use the codes to differentiate them. But CDMA, I think most of the time, people were still talking about more or less not overloaded, meaning if you have a certain amount of bandwidth, then you will just pack that amount of user into the system. But later on, people found that it's possible to pack more users as long as we can do a better coding. So one of the examples is the so-called sparse code multiple access. And this is from this paper, which is from Huawei. And the idea is that you not only do coding for the different devices for their signal, but also you try to put them on, say, different radio resource bandwidth or time. And then this is one example. So you different users will be occupying different resource and with different coding. And eventually, when you put them together, the system becomes a sparse system. So it's possible to use sparse detection, right, like compressed sensing. So eventually, it's possible to have more users than the bandwidth or resource. So in this case, 6 users are using 4 resources. So it's 1.5 times overloaded. So for this kind of design, it's called codomain norma. And actually, like I said, even before this paper, there has been a long history, like IDMA, which is using turbo code and with different interleavers to differentiate different people, right? So it's called IDMA, and there have been others. I think this the paper by Linglong Dai and also Lyle Senso, they have done a very good job summarizing. So I just cut the picture from that paper. So basically, you can see that for 1G, 2G, 3G, and 4G. Actually, 3G is CDMA. It's already somewhat non-orthogonal. But then 4G, again, is orthogonal multi-access. So they compare this with recent norma, and you can see that there are different things. But in this talk, we will focus on power domain and codomain. Okay, so, and actually, like I said, if you look into this problem, norma is not new at all. Right, and also another paper by Professor Hensel, which is, I mean, he's an expert in norma. So it's very good. They actually list the history and a lot of papers. So for example, the so-called successive interference cancellation already appeared in Professor Thomas Cover's paper long time ago, right, 1972. And then we also have similar things for broadcast channel, etc. And later on in Professor David Shea's seminal book, he actually introduced a lot of ideas and also his research. So he compared norma with OMA, non-orthogonal multiplexes with orthogonal multiplexes, and to show that, okay, in what situation norma can buy you gains, okay? Yeah, so like I said, in theory, there have already been many results in the non-orthogonal multiplexes. And people have shown a very good advantage of norma in both the multiplex channel as well as the broadcast channel, which is for the downlink, okay? So in general, we can see that most of the design that can achieve capacity is non-orthogonal. So there's nothing new. And also, not all the norma schemes can be a capacity achieving. For example, the SIC that we have just mentioned, it's good for single antenna, single in, single out. But if you were talking about MIMO channel, multiple input at the, say, for example, at the base station, and when the user device also have multiple antenna, then in that case, there's no notion of SIC because the channel is no longer degrading. For example, since you have many antennas, right? So some of your antenna might have better gain, some of your antennas might have worse gain. So when you mix them together, it's not very sure which user has a better channel. So in that case, if you try to do successive cancellation, then first of all, it might fail, or you have to reduce the rate, then it is not capacity achieving, okay? So, so NORMA, according to, say, the 2013 paper from Docomo, actually, in the example, they talk about CISO, but actually for MIMO channel, it may not work, okay? And also, NORMA does not always provide significant gain. So if you have, in the example that we just mentioned, you have two users, one is closer to a base station, the other one is farther away. But if two users are very close, in location, then their channel are almost identical. In that case, you actually don't get any gain from NORMA. You can just achieve the capacity by using OMA, the orthogonal multiplexers. Okay, so the authors from that 2013 paper, later on they also submitted one journal version to IEIC. So I think they have shown it very clearly. So in these figures, the bottom two are for the multiplexer channel, meaning the uplink. And when you have two users that have different SNR, for example, in this case, you can see that this is the so-called capacity region. So the x-axis is for the achievable rate for the first user, and the y-axis is the rate for the second user. And so we can see that the capacity region, meaning, say, the maximum rate pair that can be achieved by the two users, of course, this is just one example, will be on the boundary of this pentagon. Okay? And this is achieved by successive cancellation for this CISO case. Okay? Especially the CISO will work in the corner and also the boundary here. Okay? And if you try to do OMA or orthogonal multiplexes, then you will get the red dash curve here, which is a little bit smaller regarding the capacity region. And when you have two users that have very similar channel condition, then actually you don't see the gains because even for OMA, there's a point the OMA can achieve the capacity region. So in that case, it's good enough if you were only concerned about the total sum rate for the two users, right? And for the broadcast channel, it's the top two figures. So basically, how do you get this? According to the uplink-downlink duality from Professor Goldsmith and her students, Nihal Jindo and also Visvanas, they have shown that uplink and downlink are actually dual problems. And if you try to get the downlink result, then you can just work on the uplink result, which is convex. So you can work on the uplink result and then take the same result and convert it for the downlink. Then you can get the same sum rate. And actually, later on, they also show it can achieve the capacity. So how do we get this capacity region? It's basically you take the pentagon here, and you adjust different powers for the two users. And then you put all the possibility inside and take an overhaul, and the upper bound will be the capacity region for the broadcast channel. And in here, we can also see that OMA is this one here. It's a straight curve. Basically, it means that you have two users, and if you let them do orthogonal multiplexes, which means that one user will be transmitting at a particular time, and the rest of time will belong to the other user. So in that case, they can do time sharing to achieve this curve. But this is for the case where their channels are according to a particular result. But say in this case, when the channel is worse, then you can see that NORMA and OMA are actually very similar. So yeah, the reason I'm showing this is that basically we know a lot of these results already theoretically. And also in terms of, say, practical system to achieve this kind of design, in the paper by Weingarten and Sharma et al., they have actually proved that if I use a certain coding design, which is called dirty paper coding, then it's possible to achieve the capacity region for the broadcast channel, which is non-convex. So in this case, it's not as straightforward as the multiplexer channel for the uplink. Okay, and say when I'm an editor, I saw a lot of reviewers saying, okay, dirty paper coding takes a lot of complexity, so it's not practical. But anyway, if you look at the design by Aris and Sharma and Zamir, you can see that this is a lattice-based dirty paper coding. And actually, you can see that in your encoder, you will be subtracting the so-called interference, right, at the transmitter side. And then after all, when you signal get to the receiver side, because during the transmission, the interference will be added back. So they cancel each other. So basically, this kind of design, dirty paper coding, it can be considered as success cancellation at the transmitter. Okay, so basically, what you can do at the receiver side, you can also do at the transmitter side. And in fact, it's much, say, cleaner to do because at the transmitter side, if you are talking about the broadcast channel, right? For example, the base station is trying to transmit to the two users non-orthogonally. So in this case, when you consider one user, the other user signal will become the interference. So since the interference is known to you, a base station, so you can cancel it at the transmitter side, and then it will be completely canceled. And then at the receiver side, the receiver does not even need to worry about that. Okay? So, so it has been shown that the dirty paper coding scheme can achieve the capacity region for the downlink broadcast channel, meaning the downlink norma. Okay, so after I've talked so much about norma, so what is new about this particular term norma? I mean, it's just some new applications of the old theoretical results, or is it just some way to implement with low complexity, but of course the performance will be affected? I would say eventually the result will be scenario dependent. So I put this very famous saying, I'm from Taiwan, so people from Taiwan are very familiar with this term. One China with respective interpretations, right? So China is China, they would like to call themselves China, and Taiwan would also like to call us Taiwan, China, sorry. So, we're a little bit more like forced to say that we are China, because we cannot say that we are Taiwan, because then, you know, US and China, and even some people in Taiwan will say, okay, you are trying to separate from China, you are trying to be independent, that's not allowed. But anyway, so eventually the scheme was that one China, so we can say that we are China, and we have certain definitions, and China can say they are China, so they have also their definition. So in this case, I think one norma with respective interpretations, you can say that your scheme is norma, but you know, you just have to define your scenario and everything. Okay, so through observation, and also I quote from Professor David Shea's book, that if you have a very asymmetric channel for your users, then it's the scenario to use norma, and then you can get a lot of gains. And the reason is quite simple, right? In the previous norma example that we have given, one user has a weak channel, the other has a strong channel. So in that case, the user with the strong channel actually is not, you know, limited by the interference. It is limited by the degree of freedom of the channel. So it can fully utilize the channel. While because its channel is good, so it can easily get a high data rate with a very small power. And this small power will cause only a little interference to the weak channel. So it may not be that much a deal, right? So, so for both users, you gain this way. Okay, so I would like to show one example that we have considered a few years ago, which is the asymmetric situation in the device-to-device communication. So basically, this is the figure for device-to-device communication. So we have a lot of devices or UEs who are trying to communicate with the base station. And usually what we do is that the device will send signal to a base station, and if the signal is for other users, then the base station will be kind of like a relay to send the signal down or send the signal to other cells. But in many situations, if two users are very close to each other, then we can basically let them talk to each other without going through a base station. And because they are very close to each other, then the users can use very low power to achieve a very high data rate. And this is why D2D was introduced to the standards. And I think in the beginning, a lot of possibilities were mentioned, but later on, nowadays I think maybe eventually it became the side link for vehicular communication. But I think in terms of, for example, social network or location-based services, I think the D2D scheme will still continue to develop. And so basically, feature of D2D is that we can get a high rate, and because the users don't need to get through the base station for transmission, so it will have low delay and low power consumption. And in the standards, currently, they are doing this, which is called overlay D2D. So a particular slot is reserved for D2D, while the remaining times are for uplink. Okay, the reason it's allocated for the uplink channel is that D2D is mostly initiated from the UE, right? So, so when UE is trying to send signal to another UE, it's transmitting. So using the same channel as uplink will be much easier. So in this case, we observe that for each user, it may have the signal for its neighbors, but it can also have signal for other cells, right? So each user actually can have both traffic for the cellular traffic and also D2D traffic, okay? And instead of doing this so-called overlay by dividing your resource into D2D slots and uplink slots, we can actually let a UE to transmit at the same time and same frequency to the base station for uplink and to its neighbor for D2D. So that is non-orthogonal, right? And it's very asymmetric because the neighbor is very close, so this channel is very good. And for the uplink, the base station may be far away, so the channel is very bad. So in this case, it's asymmetric, and you can get a very large gain. Okay, so yeah, so I think the idea is very simple, and how do we implement this? So what we have in mind is like this, okay, so this particular UE is trying to transmit signal to both the base station for the traffic that is destined far away, to other cells, and it is also trying to send signal to its neighbor for D2D communication. So in this case, the orange arrow means the signal to the base station, and the blue arrow means the signal to the D2D. And the dash arrows are the interference between them. Okay, so in this case, if the user can do this, then we need to figure out how to achieve this, right? And the first thing that we thought of was to use dirty paper coding. So for example, this user device can do dirty paper coding for its D2D signal. So if it, say, encode the uplink signal first and then do dirty paper coding, so for the D2D, so when the D2D signal is encoded, it will treat the uplink signal as the interference. So we can use the interference cancellation as a transmitter to cancel it out, right? So, so in this case, then we can see that for the D2D link, the strong interference for the uplink signal can be completely removed. So the communication for D2D will be very good. While the D2D signal has good channel, so only a little power will be allocated to the D2D signal. So the interference that it is causing to the uplink channel will be very small. So the uplink channel actually will not be affected that much. Okay, so this is the optimization problem. So we try to optimize, to maximize the sum rate for this kind of transmission, while still keep certain amount of uplink traffic alive, because that is very important to be transmitted to other cells. So we have this constraint. So the R1 is for the uplink, and then it has to be larger than a certain amount of the pure uplink transmission. So it can still keep some part of that. And so this is the summary problem with constraint. And previously, I have said that for MIMO broadcast channel, which is for this kind of application, it is NP hard, so it is not that easy to solve. And if we are looking at the sum rate alone, then there's a paper which proposes iterative water feeding, which can achieve the maximum sum rate, but that is without a constraint. So in this case, we have the constraint. So how do we deal with this? We look at the problem and eventually see that in our case, the capacity region will have these three possibilities. Okay, so again, the x-axis is for the uplink rate, and the y-axis, R2, is for the D2D rate. So first of all, we can use the iterative water feeding to get the maximum sum rate. And the maximum sum rate could be at the corner, right, like here, or it could be at some point on the capacity boundary. And so in this case, we have found that if it's in this corner, which means that the uplink channel actually is even better than D2D. So in that case, we don't need to allocate anything to D2D. So the problem is solved. And if in this case, or in this case, we're not sure how to encode uplink and downlink, because it's a MIMO channel and you don't know which better actually is better, depending on which corner or which point on the boundary that you are. But if we look at the duality problem, right, this is the capacity region for downlink, which is this boundary. It is actually the overhaul of the multiplex channel, right? And we can see that for us, there's a constraint for the uplink channel. So we would like to keep the, say, minimum amount of rate alive. So in that case, we will favor the uplink channel first. And if we do that, then it's like, no matter which point here, actually we are looking at the, say, the MAC channel boundary, the lower corner here, when it touches the boundary. So yeah, so this may not be a good example, but in this case, you can see that it will be this lower corner for all the pentagons to touch the boundary region. So in that case, we have also omitted the order for encoding. So basically, we don't need to worry about encoding. The encoding will always be encoding uplink signal first, and then doing dirty paper coding of device-to-device communication over it. Okay? So eventually, by doing this, and then we also modify the iterative water feeding, and then we can get a very good result and with low complexity, because you don't need to worry about the encoding order, and you don't need to solve the optimization problem. You can use iterative water feeding. It's kind of like regular water feeding, but multi-user. That's all. And so the nice thing about this design is that we can put it on top of any of the D2D design. For example, for the overlay D2D, even though there's a particular slot reserved for D2D design, but for the uplink design, we can also introduce D2D to that slot without affecting the uplink too much, but increasing the D2D rate a lot. And usually that time slot is much longer, so you have a lot of time to transmit D2D with very little power. So eventually, the result will be very significant. So in this figure, which is for the overlay D2D, we just put our design on top of the D2D in the standards. And the y-axis here is the sum rate for the uplink slot compared to the case without D2D. And we can see that we can achieve, with these two curves, we can achieve like 2.6 times of the rate. Oh, and by the way, the x-axis is the number of D2D pairs in the network. Of course, the more D2D pairs, the more offloading of the signal that you can do, so you will have better performance. And then we also apply this to underlay D2D. And for underlay D2D, every device can transmit D2D or uplink, whatever you like. So in this case, it's a bit more complicated, but the performance will, of course, will be much better. So in this case, we also say combine our design with some designs in the papers for underlay D2D. And as you can see, so original design is here, and we can improve by like 3.5 times. And this is another set which belongs to another design in the paper, which is already very good. But if we put our design on top of it, we can gain another like 60% of the transmission rate. And after that, we also compare the 30 paper coding based design with the SIC based, meaning now we also consider, say, if the receiver, meaning the D2D receiver, can do successive cancellation. So this is for successive cancellation. This is for D2D. This is for 30 paper coding based design. So yeah, so basically, you can see that 30 paper coding, of course, will provide a better gain. But some people say that it has higher complexity. But if you use a lattice-based design, you can control the block size that you want. So it's a trade between the core block size and the performance. But in general, it is better. And actually, there are a lot of very simple 30 paper coding designs. For example, the in equalization, people have been using Tomlins and Hiroshima pre-coding a lot. That is similar to 30 paper coding. Okay, so yeah, I think almost lunchtime. So the last thing I would like to mention a little bit is that there are other things about nanosynchronity. So nanosynchronity can also come from the requirement for low latency. So for example, the recent grain-free communication is targeted at low latency, right? Because you don't want to do the handshaking, so you can save the time for synchronization. But in that case, you have low delay, but the users will have asynchronous communication. So in that case, the performance will not be good. And it is another kind of nanosynchronity. So we also try to solve this problem. The idea is quite simple. We know resolvent code and BCH codes are so-called transform codes. So they have their regular interpretation in time domain, but they also have their dual interpretation in the finite field frequency domain. So in that case, if we say put the data in the frequency domain and then transform that back to the time domain and put the cycle prefix, it's similar to OFDM, but it's already coded with very strong code, resolvent code, or BCH code, depending on whether you want to do binary coding or non-binary coding. So this is how we do. And in time domain, when there is a delay between user signals, that delay actually becomes a phase rotation in the frequency domain, in the frequency time domain, right? I'm sorry, frequency codomain, right? So in that case, we can embed maybe one pilot symbol into a frequency, finite field frequency domain, and when you receive signal, you just have to check that symbol to see what's the phase rotation, then you will know the delay. And even with all the delays, it's like OFDM, these codes will fall in the original lattice with the different combination due to the channel. So basically, we can do joint decoding, like for example, using that code, integer forcing decoding. And so the result is very interesting. So SCMA is like benchmark people are comparing to nowadays, right? So this is SCMA if all the users are synchronous. But if the users are not synchronous, then SCMA is very bad. And in our design, when we consider asynchrony between users, then we can still get very good performance. And these are, the other two are just using a similar design, but just OFDM combined with coding. And the results are not as good because the code is not good enough. Okay, so for conclusion, I think normal or non-orthogonal transmission has been there for a very long time. And it's been rediscovered in recent years. But I think for younger researchers or engineers, I think it is good to know the history so you will know what has been applied and what has not. And there are a lot of normal schemes nowadays because, like I said, we want more efficient in terms of bandwidth, in terms of delay, and in terms of number of devices supported. So everything will be non-orthogonal. It's just how you discover the difference in the scenario or the requirements and how you apply the existing results, or in the case that we just mentioned, the downlink broadcast channel with rate constraint for one of the users. That problem has not been treated before, even theoretically. And through the design, we also found, say, the theoretical result for that kind of situation. And also, through observing the particular application, eventually, we came up with one design which is very low complexity. And it can be implemented, and it helps D2D communication a lot. So with that, I'm happy to take questions. Thank you.
This proposed design, how much it will be useful for the IoT applications. So for cellular cases, we have seen, right, for cellular users. Yeah. But if we go for IoT devices, okay. So how much is suitable and like this design will?
Yeah, I think device-to-device communication also includes IoT, because IoT nowadays, you can have a swarm of IoT, for example, UAV, and they can communicate with each other, and maybe there's one cluster head which is going to communicate also to the base station or the server nearby. So that you can also apply this idea in that situation. Yep.
So in terms of energy efficiency, I think you discussed about the latency aspects.
Yeah.
But what about the energy efficiency with respect to the classical approaches and other energy efficient techniques that NOMA provides?
Okay, yeah. We did not specifically compare energy efficient in this case, in this particular paper, but we are also doing that. And it's, I think there are two things. One thing is that once you include the energy efficiency, then even the Shannon capacity or similar definition has changed. So that is one thing. So we need to factor that into the optimization. And also the other thing is that usually, say, if you, in that case, you also need to consider, say, so far what I have considered is like the transmission power. But in that case, you also need to consider processing time. And I have not shown here, but we have also done some results by considering, for example, dirty paper coding, and like I said, it's a lattice, so you can consider the dimension of lattice. And the smallest lattice is just one symbol, right? So basically, it will be similar to SIC. But if you consider higher lattice size, then you get good performance. But in that case, it will depend on how you implement. And so, like for that example, we have also tried using trace-coded quantization. So, the lattice and the modular operation then can be converted into very simple trellis search by using Viterbi algorithm. So that would be, in terms of energy efficiency, that part can also save a lot. Yeah. So yeah, I'm not quite sure if I have answered your question, but.
Yeah. So basically, I was looking at, you see, there is a NOMA, there is a primary objective to start with was the rate enhancement. Right?
Okay. Right.
But the energy is, because SIC comes with a lot of energy overhead.
Right.
So I was actually looking from that aspect. So if the receiver side also, when I have to cancel the interference, I have to do much extra processing compared to. Right.
Yeah. Well, I think this is also kind of like an asymmetric system. So, for example, if I do interference cancellation at the base station, then, if you just consider pure energy efficient according to the formula, then maybe it probably will cost similar amount of energy. But if you consider that the base station, you can have the plug, so it will be much easier than doing the cancellation at the UE side. So that is, I think that is another advantage. But yeah, again, I think for energy efficient, I think there are very, say, formal definitions. And in terms of analysis, we have not done that yet. We only have done, say, through simulation and how much power that our processing will cost. So we have done that, and in general, I think if we use those kind of simple coding, then it's still not bad, I would say. I'm not sure if it's optimal because we don't have the analysis. It's just simulation. Yep.
Thank you.
Thank you.
So, one similar question is this transform coding you have written, so that transform coding is better than for existing NOMA. Yeah. So we already assume that some of the error correcting techniques are already there. Yeah. So apart from those error correcting techniques, you are talking about this transform codes, or like in addition to that, or like this only? So it's on this.
Oh, okay, yeah. In this case, it's on. So, it kind of like combining modulation and that sparse code together into one thing, and that thing is the resolvent code, which is maximum distance separable. So, so in this case, the code structure itself is good, and all the users' code will fall on the same lattice, so they can be jointly decoded. And the only one thing that we are still trying to figure out is that, so in this case, so far, the existing decoding for, say, this kind of multi-user, for resolvent code, most of them are still hard decision decoding. And we are trying to figure out if we can have soft decision or massive passing. So we can, for example, we can have good performance even when all the users are synchronous. So in that case, if we can, so far, when users are synchronous, the performance of our design is still worse than the CMA. But we are sure, of course, SCMA is based on massive passing. So in that case, So the answer to your question is it's on. So once we have shown this, then maybe, you know, the, right.
On top of that, you're talking about the transform coding?
Yeah.
For showing it is better than the existing NOMA.
It is better, but like, for example, for SCMA, it's also like, you know, you're putting code in a very short period of time. So on top of that, you can also put turbo code and everything. So I think our design is trying to replace that part. Yeah. Yep, thanks. Yep, thank you.
Thank you so much. And thank you, Biplav, for coming. And thank you, HJ.
Yeah,
I'm sorry, I don't call you both professors anymore.
है लैपटॉप?
तो इस मारे रख दिया। कौन सी है?
एक ही है ना,
कॉपी करें मुझे?
कॉपी करके पेस्ट कर दीजिए वहाँ पे। और एक इसमें भी एक डाल दीजिए वही वाला।
इसी में कर दूँ? इसी में?
TS नहीं, TS11 में नहीं, पीछे पीछे जाइए।
पीछे एक ही फोल्डर दिया ना हाथ में।
TS11 एक फोल्डर कहाँ है? अच्छा, इसमें डाल दीजिए। इसमें यहाँ पे पेस्ट कर दीजिए, बाहर ही। हाँ,
इधर कर दे रहा हूँ।
इसमें पेस्ट कर दीजिए।
हाँ, इसमें पेस्ट कर दिया। इसमें भी डालिए ना डेस्कटॉप में।
So good afternoon, everyone. So we have this special session here on AI-enabled wireless network. So for this session, we are having two session chairs with us. I would like to introduce them. The first one is Professor Dr. Ashok Kumar. He is a distinguished professor of physics at Sharda University. He has a remarkable academic and research background. He completed his PhD in solar and space physics from Johns Hopkins University, where he was also the part of prestigious solar flare Genesis telescope and magnetograph project, which he was honored with US National Science Foundation's Antarctica Service Medal for USA. Dr. Kumar's research spans prestigious institutions such as Stanford University, where he worked on microfluids, and Massachusetts General Hospital and Harvard Medical School, where he contributed to advancements in medical imaging and image processing. His work also reflects to the research and development in biomedical instrumentation. His interdisciplinary skills bridge fundamental physics, applied research, and industrial innovations. So with solid academic foundations and diverse research experiences, Dr. Kumar embodies a blend of theoretical and applied scientific excellence. Please welcome Professor Ashok Kumar. Next, we have with us Dr. Sanju Tiwari, who is a professor at Sharda University and former DAAD postdoc NET AI fellow. Having visited multiple German universities, she was a postdoctorate researcher at Ontology Engineering Group in Spain and serves as chair of ORKG user board at TIB Hanover, Germany. She initiated DBpedia chapter in Hindi. Dr. Tiwari co-supervises PhD candidates in India and previously contributed to a DRDO-funded defense project at NIT Kurukshetra. Her research interests include ontology engineering, knowledge graphs, and AI. With over 100 publications and 6 Scopus indexed books, she actively participates as a journal and program chair in prominent international conferences and serves as a guest editor for scientific journals. So Dr. Tiwari is also speaker for IEEE and IETE into women's empowerment events and international radio programs and has conducted research in 7 countries. So please welcome Dr. Sanju Tiwari. So I would like to invite the authors for the first publication, paper today. That is paper ID 15710807555, Analysis of Image Captioning Approaches from a Deep Learning Perspective. The paper is authored by Ms. Monica Chawla and Rashmi Agarwal. Sir ने बोला पहले ऑफलाइन ही करा दो. दूसरा सेशन वेट कर रहा है तो उन लोग का भी ऑनलाइन सेशन है तो क्लासेस हो जाएगा. So, so we have some online presentations here. So we would like to invite another paper ID 15710666516, Sentiment Analysis on Conversational Data Using Deep Learning Methods.
So, madam, can we start?
Yes, you can start.
Okay. Good evening, sir. Good evening, madam. Good evening, everyone. I am Ruksha Sarkar from College of Engineering and Management. I am, and my, okay, share. I am Ruksha Sarkar from College of Engineering and Management, Kolaghat. My co-authors are Joydev Mishra and Ruchira Noshkar. Today, I am going to present my paper, Sentiment Analysis of Conversational Data Using Deep Learning Method. So, to know about this, we today's agenda are introduction, related work, problem statement, methodology, implementation, result and discussion, conclusion and future scope, and references. So the first topic is introduction. So in introduction, we have to know first what is sentiment analysis. So sentiment analysis is the analysis of someone's opinion or emotion or attitude from a written text. Suppose if we have a sentence like the laptop is very great, this sentence is author is talking about a laptop and it is great. So from this sentence we can understand that the author is reviewing a laptop and her or his perspective is positive. So that's why sometimes sentiment analysis is also known as opinion mining. So sentiment analysis can be used in different cases such as brand mining, market research, improve customer services, etc. So nowadays sentiment analysis domain is kind of saturated, so we focused on aspect based sentiment analysis. So the aspect based sentiment analysis is actually a text analysis technique which categorize the data by their aspects and then identify the sentiments of each aspects. Suppose here you can see that the example we have an example that we had a great experience at the restaurant. The food was really delicious, but the service was kind of bad. If we see the first part of the sentence, then we can understand that it is a positive sentence, because they said we had a great experience in restaurant. Then great experience is actually a positive word, so we can say that this is a positive sentence. But if we see the next part of the sentence, if we analyze the sentence on the basis of food aspect, then it is also a positive sentence, because delicious is also a positive word, so we can say this is also a positive sentence. But if we see the last part of the sentence, the service is kinda bad. So after analyzing on the basis of service, the it turns out the sentence is actually a negative sentence, because bad is a negative word. So we can say that the so we can say that the sentence is actually a negative sentence. That is why we often called aspect-based sentiment analysis as a feature-based sentiment analysis. So actually here we have followed some flowchart from where we did this work. So first we took input, then pre-process, then word vector analyze, then we have then aspect term detection, then aspect sentiment classification, then sentiment polarity. So the next part is related work. So this is the paper from where we
Madam, please put your slides in the slideshow mode, and your voice is a bit slow. Can you be a bit louder?
Yes.
Please put your presentation in slideshow mode as well. Thank you.
Okay. Madam, can you hear me? Hello?
Yes, I can hear you.
Okay.
Now it is in slideshow mode.
Okay, thank you. So this is the two paper from where I can I used to learn sentiment. I learned about sentiment analysis. The author used LSTM. Both the author used LSTM approach, and the accuracy of their works was 84.51% and 98.31%. And later we have focused on aspect-based sentiment analysis. So in the first work, author worked on a different data set like DBS data set, 2015 data. where the accuracy was 65% and 55% of 10 aspects and 20 aspects. Next, the author worked on semi-eval 2016 task 5 data, and they used RNN algorithm, and the F1 score was 48%. And next, the author worked on semi-eval 2016 task 5 dataset, and they used CNN plus aspect token, and the accuracy of the dataset was 59.83% for laptop data and 45.55% for mobile dataset. So our problem statement is actually next part is problem statement. So we have focused on actually same-eval 2014 dataset, which is task 4 dataset, and they give us 4 types of subtasks, but we only focused on 2 subtasks, which is subtask 1 and subtask 2. The subtask 1 is aspect term extraction, and another one is aspect polarity extraction. So the dataset description, but we actually got 2 type of dataset. One is laptop dataset.
Recording in progress.
Laptop dataset description. So actually we got both the dataset, laptop dataset and restaurant dataset. Both the dataset consist of over 3000 English sentences, and both the dataset consist of human annotated aspect terms. So next part is methodology. So for aspect term extraction, we have done nothing about, we have not done nothing very own. So we have used previous work like a dictionary based approach to recognize the occurrence of a particular term in the sentences, so which can be actually be a aspect term. And for the sentiment polarity, we use this flowchart. For this, we set up the environment, then we import the dataset in that, then we visualize the data, and then we text cleaning process and data pre-processing. Then we split the data into two parts. One is trend part, another is test part, and we import the training data into the model, and then we fit the testing data into the model and to get the final output. So implementation part, we actually use two types of data visualization part. One is word cloud and another one is polarity value count. So which is actually a bar graph. So the word cloud is actually used for the aspect term detection. We can see in this two photo that computer, crate, Mac, screen, laptop, and in the below one service, place, food, table, price. This type of word are coming simultaneously. So this can be a aspect. That's why we use word cloud. And in the next part, we actually done a bar graph, which is used for actually used for polarity count. Here we have got four types of polarity, which is neutral, positive, negative, and conflict. And this conflict part we have deleted, or we have removed the conflict part, and shortened the dataset. Next part of implementation is text cleaning and pre-processing. So in this part, we have done a step-by-step process like lowercasing the data, remove the punctuation and numbers, remove the HTML tags, remove the extra spaces, remove stop words, and tokenization. Sorry. So in the first part, we have done lowercasing the data, which means if one word is in capital letter and another one word is in small letter, the machine will understand both the words are in different. So both the words are different. So we have done we have lowercase all the words to easiest to make easy our work, and then remove the punctuation and number. So the number and the punctuation are not very useful for our work. So we have removed the numbers and the punctuation. Next part is remove the HTML tags. So HTML tags are also not very useful for our work. That's why we have also removed the HTML tags. Removing extra spaces. Sometimes we often understand that some of the users use extra spaces while writing any comments or while writing any reviews. That's why we we remove those extra spaces to form to fit all the data in a particular format. And removing the stop words. So stop
Excuse me,
words are
Rupsa. The total time, presentation time is 15 minutes, so you need to be careful.
Yes, madam.
Presentation time is 10
Okay,
minutes,
ma'am.
leaving 5 minutes for question answers. So we'll ask you to hurry up, okay?
Okay, ma'am. Okay, sir, I am. Okay. So the stop words are some not very useful words. So we have also removed the stop words. And next, the tokenization. So tokenization part is actually tokenization is actually a unit part of a sentence. So we have done that in our work to use a unit part of the sentences. So next we have used GPT-2 model, which is a generative pre-trained transformer, which is an OpenAI large language model. And this is actually a decoder architecture, and this model actually used mask multi self attention. And next layer is layer norm, and next part is feed forward network. And this part is actually because of this part, we can understand the polarity of a particular sentences on the basis of any aspect. So result and discussion. So we have after doing our work, we can see we got F1 score on the negative sentiment 0.64. The neutral sentiment, we got the F1 score 0.46, and on the positive aspect, we on the positive sentiment we got 0.79 on laptop dataset. And on restaurant dataset, we got the F1 score on negative approach is 0.58, on neutral approach is 0.35, and the positive approach is 0.83. And this is the confusion matrix of our work. And conclusion and future scope. So there is a difference between the traditional sentiment analysis and aspect-based sentiment analysis, and we can understand the F1 score and the result are not very good like traditional sentiment analysis, because the GPT-2 actually a generative model which can generate the next word by judging the previous token or previous word. So that's why we got not very good score in that. After pre-processing the data, the model predicted the result and predicted the sentiment polarity by judging the aspect of previous by judging its aspect of previous token. So, and these are the references from where we actually got inspiration about this work. And thank you for giving me the opportunity to present here. Thank you.
Thank you, Rupsa. Can you hear me?
Yeah, madam.
Okay. Thank you for your presentation. So I have one question that you have used the dataset challenges SM eval from 2014 to 16. So is it meant after 2016 there is no dataset, or you did not used in this? And if you did not use, why you didn't use?
Actually, I got the dataset after that, but I used that 2024 dataset, 2014 dataset, because I thought it will be a little bit easy to do this. After that, I will definitely use the dataset we got.
I mean, is there any specific reason to use 2014 to 16?
No, madam. No specific reason that
And
for doing this.
okay, thank you. And I also want to know that which steps are involved in tokenization that you have explained in your implementation slide. So can you explain which steps you have used in the tokenization part?
Can you repeat, madam? I can't understand your question actually.
Okay. Okay. Do you want to ask? Next.
If there are no more questions, we'll move on to the next speaker. But can you answer madam's last question?
Yeah, I was asking that tokenization that you have used in your implementation slide. So which step involved in that part?
Actually, we used tokenization for because I have already discussed about self-masking and multi-masking about GPT-2 model. So if we use tokenization, then we can actually use a particular word or a particular token. That's why we then it is very easy to implement implement the next
Okay.
word.
Okay, thank you. Thank you, Rupsa. All the best.
Thank you, ma'am.
So thank you. Next paper is paper ID 157-105-9934, PDBTM IOV, Probability Distribution Based Trust Model for Internet of Vehicles by Indu Bhardwaj, Sibaram Khara, and Ajay Bhardwaj. Paper ID 157-105-9934. PDBTM IOV, Probability Distribution Based Trust Model for Internet of Vehicles.
Yes, ma'am. Shall I share the screen?
Yeah, please share.
Is it visible?
Yeah, it is visible. Please put the presentation in slideshow mode.
Is it okay now? I have put it in slideshow mode.
The slideshow mode is not visible.
Okay, I'll first put it in slideshow mode and then I'll exit the screen. Then I'll share the screen again. Wait.
There's a lot of background noise at your end.
Just a second, ma'am. Now, is it okay?
We still cannot see your first slide. It is
Because I
somewhere in
am
between.
sharing it in slide mode, then I don't know why it is visible like this.
It does not matter. We can start in this way also. Please start your talk.
Okay, sir. Thank you so much. The topic for my presentation is probability distribution based trust model for Internet of Vehicles. In this work,
We are seeing your fourth slide, madam. Your fourth slide is visible. Can you?
I am on first slide.
I think there is some internet glitch at your end. You may please check.
So now it is visible to you first slide.
We cannot see your presentation now.
Now, is it visible to you?
Yeah, it is visible, and now we can see your
And
first
slide is
yeah.
visible. Okay. Thank you so much. In this paper, we have designed a trust model for effectively classifying the trusted and non-trusted nodes for secure communication of vehicles. These are the agendas for this presentation: introduction, problem addressed, methodology, system model, then result and discussion, conclusion, followed by the references. Internet of Vehicle is basically a distributed network which is used for information exchange between the vehicles and the roadside units. There can be infrastructure, pedestrians, communication protocols. IOV is basically the combination of
Hello,
Bonnet
can you hear me for a moment? Your audio is very poor. Please try to improve it if you can. And allotted time for speaking is 10 minutes, giving 5 minutes for questions and answers.
Okay, sir, okay. Is it visible to you loudly, sir? Is it audible to you loudly?
It is audible, but there is some disturbance coming. If you can't improve it, then please proceed.
Okay, sir. In Internet of Vehicles, basically there is very less work done in the trust models. The more work is being focused on the architectures of Internet of Vehicles. So keeping this view in mind, we have built a trust model for segregating the trusted and untrusted nodes. We have followed this related work. Wallet trust model, we have followed these trust models, and in Internet of Vehicles, we have followed these trust models. And from these trust models, we have found out that some of the trust models are using the past interaction history for their trust calculations, which is not feasible because the vehicles are interacting for very small times. And some of the trust vehicles have the problem that they are using the email ID for their authentication, which is violating the privacy of the users. Some trust models are not resilient against the attacks. Further, these trust models are also the rater-based, which does not effectively or efficiently encounter when an unknown node is encountered in the communication. So keeping these problems in mind, we have fulfilled these gaps by proposing a probability distribution based trust model. This is the problem statement. We will design a trust model that will be lightweight, providing the distributed trust calculation. It will be scalable and it will be robust against the attacks. In this proposed model, we have used the hybrid probability distribution based trust model for Internet of Vehicles that will be using two approaches, one for entity based calculation and another approach for the data based calculation. For entity based calculation, we have used the threshold based approach, and for data based, we have used the joint probability distribution based approach. The proposed model estimates that a node would trust another node up to a certain degree of accuracy based on their last communication. This model will be neither rater-based nor the rater-based. The trust values of this model will be stored online regardless of the rater and rater-based. The trust will be served as a service, and all the trust will be stored online using IoT. the entity will be capable of calculating the trust of these corresponding nodes, and they will be updated also locally online. In this trust estimation process, the trust is modeled as probability distribution problem, where every node has a property that it can calculate its own trust depending upon the interaction that it has encountered from the another node. And the node-based distribution will be on the basis of node behavior such as speed, distribution, distance with respect to the PDR are calculated after the communication to calculate the trust. And we have estimated this model with the help of simulation. From simulation, we will see that how clearly the malicious node and the good nodes will be segregated. Entity-based trust evaluation has been done by using the threshold-based policy. We have taken the threshold theta, and in simulation, we have provided 3 different values for this theta. If the trust value of this node, which is communicating, is greater than the predefined threshold, then we will be taking it for the communication. Otherwise, we will consider that we did not trust this node. Next is database trust evaluation. For database trust evaluation, the probability distribution approach has been used. The entity will check the integrity of the packet by taking various statistics like packet delivery ratio, packet loss ratio, average speed. If the integrated check passes, then it will be confirmed that the node has acted in a good manner, and which will make it as a direct trust vector, will be incremented based on its behavior. And if the integrated check fails, in that case, the trust vector will be reduced. The probability distribution for the estimating of the trust of the nodes, we have used the notation TAB, that is the trust in node B by node A. That is defined by this formula, probability distribution of S1 by PS1. This is basically the conditional probability of the normal statistics. We have taken the different statistics like its distance, its speed, packet delivery ratio. So all these statistics will be taken, and on the basis of these statistics, then the probability estimation will be done. If the probability, this is the probability distribution curve. If the value of the packet delivery ratio of these statistics will lie in between the mean plus minus 2 standard deviation. This is the mean minus 2 standard deviation, mean plus 2 standard deviation. If the value lies in between this portion, then we will consider that the node is trusted. And if the value of trust value lies in beyond this area, then we will consider that it is untrusted. This, or you can say, abnormal behavior. So this is the value of statistics. If the statistics lies greater than mean plus minus 2 standard deviation, if it is lying beyond this, then we will consider it abnormal. If it is lying within this area, then we will consider it as a normal node or the trusted node. For simulation, we have used the simulation urban mobility model, MATLAB, and OpenStreetMap we have taken for Manhattan City, and pre-sale we have used for the interaction of MATLAB and Sumo. And for the evaluation of this, we have taken the performance matrices, packet delivery ratio, average trust, and transaction number growth. These are the results. We can see we have obtained the results for the average trust, and we see that the value of average trust generally gradually increases for every successful interaction. We have taken 3 different thresholds. Theta is 0.75, 0.70, and 0.65. For all the threshold values, the average trust is gradually increasing with every successful interaction, and it is decreasing with every misbehavior. We can show that the average trust of the normal nodes are continuously increasing, and average trust value of the abnormal node or untrusted nodes are continuously decreasing. So this way, on the basis of trust value, the nodes can be segregated as trusted and untrusted nodes. Next parameter is packet delivery ratio. Packet delivery ratio will tell how many number of packets will be successfully received by the target node to the total number of packets sent by the source nodes. So this simulation shows that average packet delivery ratio varies with the time for both normal and abnormal mode. Ideally, the value of PDR should be as high as possible. So we see that for normal nodes, this value is very high, that is 0.006, and for all the thresholds it is greater. But if we see the packet delivery ratio of the abnormal nodes, that is 0.015, that is very low value. So on the basis of packet delivery ratio also, we can segregate the normal and abnormal nodes. Next is transaction number growth. In transaction number growth, we have compared our proposed model with the rater-based model that is cited at the paper 22 and the rater-based model that is cited in the paper number 23. We have compared our model with these two models, and we see that in the long run, this yellow color is our proposed model. So we see that in long run, our proposed model is better than the rate-based model as well as rater-based model in terms of transaction number growth in each year. Total, we have taken the simulation for 10 hours. So initially, our system was not performing well. This was because we have taken the initial trust value of 0.5. So in that case, maybe there are some malign node to which we have assigned the values, but with time, they will be segregated as the abnormal node, and the transaction number growth will be increased when the nodes will be segregated from the normal nodes. This is the conclusion. So in this work, we have presented a probability-based trust model, which is neither rate-based nor the rater-based. Moreover, the trust values are stored online at the trusted center, making use of Internet of Things. The simulation shows that model is segregating the trusted and untrusted nodes on the basis of trust values as well as on the basis of packet delivery ratio. The model is scalable in the sense that we are storing the trust value on limited set of nodes that are required only for this communication. This model is not using any cryptographic approach, so this will reduce the complexity of the model also. And on the basis of comparison, we see that in the long run, our model is outperforming the both rater-based model as well as the rate-based model in terms of transaction number growth. These are the references. Thank you.
Thank you. Are there any questions from the audience? Okay, thank you very much. We'll move on to the next one.
Thank you so much, sir. Sir, may I lead?
Yes, you may please.
Okay, thank you so much, sir.
Next is paper ID 1571095019, Advanced Heart Attack Risk Prediction Using Stacked Hybrid Machine Learning. Authors are Rudraksh Singh Bhaduria, then Ikra Javed and Anirban Khara.
Yes, ma'am.
So you can start with the presentation.
Okay. Am I audible clearly?
Yes, you are audible.
Okay. So good afternoon, everyone. My name is Rudraksh Singh Bhadoria, and this is a paper based on advanced heart attack risk prediction using stacked hybrid machine learning model. Okay. So these are the topics which we are going to cover in this whole presentation. Introduction, contribution, novelty, methodology, and then we have tools used, design of workflow, result and discussion, then conclusion. At the end, we will move towards the references. So first, moving towards the introduction, we have three main things: what it is, why is it important, and where it is applicable. So let's first of all go with the what it is. So machine learning framework using a stacking hybrid model, random forest plus XGBoost to predict heart attack risk. It's basically a hybrid combination of two models which are based on the classification model. First is a random forest, and the second one is the XGBoost. XGBoost is also known as extreme gradient boosting. Both lies under the classification machine learning Then second thing is compares with traditional models to enhance prediction accuracy. Like if we are using a hybrid model, then it's obvious like it have a higher accuracy than the uh, traditional models. Traditional models, I mean, like the other classification models which are not hybrid. Let's say if I'm using only a random forest model to classify or to get the prediction of a heart attack risk, then there could be a possibility that it is not that much capable to get me a higher accuracy if I'm comparing two hybrid models, individual models together. Then it is why it is important. So heart disease is a major cause of death worldwide. Early detection saves lives. So as it's simple and clear, like if we are able to predict the future, then it is very helpful for us. We can manage the things in the same way. Then machine learning offers cost-effective alternative for early risk assessment. Then moving towards the further, then we are having where it is applicable. So we can use this whole sort of thing in the hospitals, in the clinics, in the healthcare system for routine screening. And then second is ideal for remote or uh, under risk code areas supporting early interventions. Means if any of the places in a remote area like villages or something, and there the clinics and the doctors are not available at that particular time. So with the help of the machine and with the help of the algorithm, they can easily go on with the workflow. Then we have introduction. There is another part of the introduction which is named as existing problems. What are the problems which are already existing in the area? First is an invasive diagnostic. Like traditional methods are costly and sometimes inaccessible. Like as I stated earlier, in the remote places, sometimes the machine is not available, or the doctor is not available. So that's why the traditional methods are not that much uh, useful in the remote areas. Second is need for accuracy. Models must avoid false positive and negative. That means if we are using any single individual model, let's take an example of random forest. So if we are taking it individually, then the accuracy is the minimum at the side, and even it can predict the false positive and false negative, which are not good for the prediction stuff. Then is a data quality. If we are having any missing values in our data, which we are using to train our models. So basically the overall data should be pre-processed and the quality should be clean, and that has to be done by the individuals like us. Then we have complex models are harder for clinicians to interpret. Like let's say if we are making any complex models, so that is a bit difficult to control on the machines which are not that much capable to work on those complex models. Then we have more non-disease cases and data make training harder. And then at last, models need validation across diverse population. Then here is the overall contributions and the novelty. What we have done in our model, we have used a random forest and XGBoost, that is a hybrid model, demonstrated the highest performance, achieving an accuracy of 89.13%, which is significantly higher than that of the traditional models. This results indicates the potential of hybrid ensemble techniques in improving the accuracy of heart disease prediction system. The use of feature importance analysis with random forest also allowed us to identify the key predictors contributing to the heart disease risk, guiding medical professionals in focusing on the most impactful factors, as heart disease is a really impactful factor in our whole society. Then second is the promising results from this study advocate for the integration of machine learning frameworks into clinical settings, potentially serving as a non-invasive tool to assist healthcare providers as early diagnosis and preventive treatment planning for the patients at risk of heart disease. Future work could involve testing these hybrid models in real-world clinical scenarios and further optimizing feature selection method to enhance the model accuracy and usability. Feature selection method is take place inside the data itself in the pre-processing part. Additionally, expanding the dataset for real-time data and exploring more advanced deep learning architecture could lead to even higher predictive accuracy. If we have a better data set, if we have a long data set, then it is really helpful to predict the future upcoming things in a much better way. ultimately supporting personalized healthcare strategies for heart disease preventions and management. So the main thing overall in this slide was the 89.13 is the accuracy for our hybrid model, which we have proposed in this paper. And it is really helpful because we have trained this overall model in a very long data set with a highly efficient pre-processed thing. Then methodology, what I have used to create this overall project work done was the data acquisition, collected data from Kaggle. The data set includes chest pain type, age, sex, heart disease, cholesterol, and etc. These are the main things, main features, and there are multiple more. Then second is the data pre-processing, clean and transformed the raw data to remove outliers, handle missing values, and scale features for optimal model performance. Use techniques like normalization, encoding, and dimensionality reduction, example PCA for this step. Like we can even combine 2 or 3 of the features so that we can get if we are having so many features in a raw data set, and what we can do is we can individually can select multiple features and then combine it in a single one, which can be done with the help of the dimensionality reduction. And the example for that algorithm is a PCA. Then third is a feature engineering, developed new features to enhance model accuracy based on domain knowledge. This included calculating derived matrices, aggregating informations over time, or using statistical methods. Then fourth is model selection. Choose a combination of machine learning or deep learning models, including LSTM, CNN, and SVM to best fit the characteristics to the data and meet the project's goal. LSTM is a deep learning model. CNN is used for the neural networks, and SVM is also a part of a machine learning model.
Rudraksh, please
Yes, ma'am.
take care about the time. Your time is exceeding.
Okay. Then we have training and testing. Basically, we have to train a model so that it can predict for the future. Then we have to evaluation the matrices so that we could get a score of how much our model is putting out the accuracy. Tools we have used are these are the main tools. Google Colab, where we programmed a overall structure coding stuff. And then we have used the Python 3.10, which is linked with the Google Colab. Then we use the frameworks like Pandas, NumPy, and Scikit-learn to initiate the models. Then this is a overall system, how this design or the workflow of our overall structure, how it is working. First is user have to input the data set then data pre-processing will take place, and then model training and evaluation will take place, in which overall model will be trained on the data set, and then it will be also evaluated with the help of the dataset itself. First, we have to split the dataset or the raw dataset into 2 things: test dataset and trained dataset. Once we have trained our model with a trained dataset, then we have to test it, and then evaluation will take place. And then we can use the plotting stuff so that we can visualize our model how it is working, like confusion matrix and ROC. Then the results, like our hybrid model gave us the 89.13, and the precision was 0.92 and recall was 0.89. And voting hybrid models followed with 88.59 accuracy and 88.04 and 86.96. And these are the key findings, the F1 score was 0.89 as the performance metrics, and the critical features. These are the critical features as mentioned, like age, ST slope, cholesterol, and all. And what we basically a result was that the stacking hybrid model really stands out on non-invasive, accurately early heart disease prediction. And these are the results. In the second one, if in all these graphs, as we can see in the second stacking hybrid models, RF plus XGBoost, that means random forest and extreme gradient boosting, is our proposed model. And it is scoring really high in terms of the same data set, but in comparison with the different models. Then here's the conclusion. This, at the right side, as we can see, there is a confusion matrix. And we can see that it is performing really well, and the ROC curve is on the good side. And these are the references which we use, few of the references which we use to cover up this overall presentation in overall research. Thank you.
Okay, thank you, Rudraksh.
Is there any question?
Yes.
Okay.
Your
Yes, sir.
methods are all machine learning methods, but you mentioned LSTM and other deep learning methods in the middle. And then you mentioned that scikit-learn has LSTM in it. You should be clear about these things because what work you have done is good enough by itself. You don't need to add on to it, right?
Yes, sir.
LSTM is present in TensorFlow and PyTorch.
Yes, sir.
Okay,
Yes,
so
sir.
that care is required. And all the machine learning methods, I think you have used only supervised machine learning methods with features given. Then you mentioned you have used k-means also, which is unsupervised method.
Yes.
So,
Yes,
you know, just adding on lots of methods does not really improve things, right? So, can you
Okay, sir, I will take care of that.
Okay. Is there any, are there any questions from the audience?
Okay, thank you, Rudraksh. Thank you for the
Okay, welcome, ma'am. Okay.
So the last paper in this session is paper ID 15710800755, Analysis of Image Captioning Approaches from a Deep Learning Perspective. So the authors are Monica Chawla, Rashmi Agarwal.
Good afternoon, everyone. I'm Monica Chawla, a research scholar from the Manav Rachna International University. And my research paper is Analysis of Image Captioning Approaches from a Deep Learning Perspective. Introduction to image captioning. Actually, my paper is starting with the image captioning and just analysis of deep learning techniques for image captioning. Starting introduction is image captioning, generation, textual description for the images. This process is involved translating visual content into the meaningful text, enabling better understanding and interaction. It involves actually object detection and scene recognition. This is the AI system analysis, the image to detect the objects and understand the context and forming the basis for the accurate captions. Sentence formulation is a key component. Actually, image captioning is totally creating a sentence actually. It is a collection of words. This ability to construct the coherent sentences from the identified objects and action is crucial for the effective captioning. Aids in automated image indexing and retrieval. Captioning allows for a better organization of visual data, facilitating faster and more accurate image searches. Crucial for the application like web searching and visual impaired users. My main motto is deep learning in image captioning. We are just using and compare the deep learning methods for image captioning. The role of deep learning algorithms are actually, we just use for the effective image captioning. There are main basic models CNN and RNN. An automatic feature derivations. These algorithms automatically extract some information or features from the images and streamline the caption process. Coherent caption generation. Next step is a deep learning facilitate the creating a coherent and textual relevant caption for the images. Advanced over the traditional method, these are the AI driven approaches outperform traditional techniques that depends on the manually crafted features and classifier. There are many deep learning based image captioning method in a day-to-day life. You just see the, right now we have a huge collection of deep learning method, but basics are only 4. Number 1 is multimodal space-based image captioning model, which is actually integration of the visual and linguist data. This is the textual information to create the cohesive captions. Feature extraction with a CNN. An application in a image captioning is that this method is specially designed to enhance the accuracy and relevance of the image captions. Shared representation means this is a common framework for the both images and text. And caption generation with the LSTM. LSTM means long short-term memory. This is the actually network which generates the neural language description for extracted features. This is the multi-space based image captioning architecture, which is having an input image, and then the process start with the image encoder. And after that, language encoder means build some words. And multi-space model then work on it. And language decoder decodes this and complete caption generated after this process. Next is dense image captioning. Dense image captioning involves the generation of caption for distinct region within an image. Regions means different parts of the image. First, we get the parts of an image, then give it the small caption, and then combine it. This is the architecture of dense image captioning. See, first we just have an image. Image has a huge data, means a girl and park, chair, table, fruits. ये reason it take small reason and combine it and give it a caption with some LSTM process. Then encoder decoder architecture, it's totally based on the CNN only LSTM architecture. Compositional architecture based captioning, it's also based on a CNN. CNN means convolutional neural network to effectively extract the semantic concept from the images. It's enhancing the actually caption generation. A sophisticated language model is utilized to generate a rank of candidate captions. It's a deep learning multimodal similarity model. This is the architecture of compositional architecture based captioning. It's having some input image, then image understands in a different parts, then visual concept is mainly text generation part. Text generate with the LSTM and re-ranking the caption. After that, we have a complete caption. My work is start right now. I have read some research paper which is freely available on the some search engines having 2014, 15, 16, 17, 18, but not latest. I know very well 2002, 22 and 23 papers are very well, but I have freely available these papers. So that's 23 papers I read deeply and conclude the data with these reference and image encoder technique which used and language models they are used. Then after that, these 4 model I just categorize with these things. In this table only, I just collect the data. And then after that, I just conclude with the result analysis. This paper contains a short analysis of experiment result, a comparison table across multiple benchmark data set for a different image captioning technique is presented in table 2, which is represented here. Data sets which are used, Flickr 8, Flickr 30K, MS Coco, and Flickr 8 having 8,000 images, Flickr 30 having 30,000 image, MS Coco have 3 lakh images. So I just analyzed all these with some existing work and conclude with the blue 1 and blue 2 score, which is a evaluation matrix, and give some results and having a better performance with the encoder and decoder architecture is the right not best technique in these 2015 and 18-17 papers. My conclusion is image captioning makes The web page accessible for the visual impaired because textual description of the image appeared on the web pages. The textual description hence enable content-based image retrieval. This paper actually serves as a systematic review because it describes deep learning technique as the basis to achieve innovation in the last 10 years within the image captioning. Despite all these, there still exists a need for a fully robust technique that may produce high quality caption for the vast diversity of images. New deep learning architecture emerges continuously, which signifies that automatic image captioning research will not just remain active, but will evolve as well. These are the references I just use for the making a table. These are, I think, 33 references I just use in this paper. Thank you very much. Any query, please?
Thank you, madam. The question madam was asking was that you have used slightly older references, only
Yes,
till 2018.
I told these are actually freely available on the sites. Any search, many search engine give freely these papers, but they are still. I know this is my mistake. IEEE membership नहीं है sir मेरे पास, so that's why मैंने वो paper use नहीं किए latest. एक्चुअली मैम जिन टेक्निक्स पर मुझे काम करना था ना वो टेक्निक्स इन्हीं पेपर्स में थी, तो इसीलिए मैंने ये पेपर्स यूज किए.
You wanted to use LSTM only. You haven't
LSTM, CNN, RNN.
Transformers नहीं देखा आपने?
नहीं, अब नेक्स्ट मेरा वही स्टेप है सर.
Any questions from the audience? Okay, a lot of growth has taken place in this in last several years because in AI field, even 1 year is very long time,
yes,
right?
Yes, sir.
So it is better that if you look into newer work in this, because image captioning, video captioning is very hot topic and has seen a lot of growth.
Yes,
and accuracy has increased by some newer methods.
Yes,
okay,
sir.
thank you. Thank you.
Thank you, sir. Thank you.
So thank you so much, everyone. I request Dr. Ashok now to please felicitate Dr. Sanju Tiwari. Thank you, sir. Thank you, ma'am. Thank you, sir. So we now have an invited speaker with us. I just take a few minutes. So she may be joining very soon. So Dr. Reena Sharma. Then we'll be having an invited talk here. So we have with us Dr. Reena Sharma on board, a senior faculty member leading in avionics specialization. Dr. Reena headed the Airborne System team and is recipient of prestigious Technology Group Award 2013 at DRDO. With a keen interest in academia, Dr. Reena is a recipient of postdoctoral fellowship at Helsinki University of Technology, Finland, and earned a PhD in microwave engineering from IISc Bangalore and MTech in radar and communications at IIT Delhi. Her deep expertise and vast experience is pivotal in grooming researchers for industry engagements and research excellence. Please welcome Dr. Reena Sharma. I request Dr. Bhuvnesh, Dean Research, to please felicitate Dr. Reena Sharma. मैं fresh please ma'am.
Whatever number we are there.
Thank you, Professor Bhuvnesh Kumar, for a nice felicitation. Just to start, before I start my talk, I would like to thank the Vice Chancellor, Professor Sivaram Khara, Dr. Madhukar Deshmukh, Dr. Avinash Kumar, and the organizing committee of WPMC 2024. So with these few words, I'd like to start my talk today. Maybe you will feel it's a little off track from the title of the conference, but I'll try to touch upon how how the system engineering perspective can be used for 6G communication, which is enabled by AI. So the organization of my talk is, I will start giving a little brief on where I am presently, the chairperson of the Systems and System Engineering Panel of Aeronautical Research and Development Board of Defense Research and Development Organization, DRDO. And with that, I will touch upon a little bit about, I thought I should give a little brief on what exactly I mean by systems engineering here, and then go on to use the system engineering principles in 6G, what are the requirements, the key performance indices, and the architecture for the 6G. And then bring out the kind of use cases in the network-centric warfare, which is the requirement in the present scenario in aerospace defense. Finally, I'll conclude my talk. So giving a little brief on the Systems and System Engineering Panel, it basically started in the year 1972. And I would like to bring out here that its main focus is towards supporting different kinds of projects and proposals from the academic institutions R&D laboratories and industries in the form of providing grants and aids for such projects, which can be beneficial to DRDO, especially related to aeronautics and aerospace defense. So the scope comprises of different types of projects or proposals which are expected from educational institutes. And it's not really limited to these things. We encourage proposals and projects up to a technology readiness level up to 3 or 4. And as and when the technology or the state-of-art technologies are getting evolved, DRDO is very much interested in those kind of projects. So it's primarily the scope is to promote research and development related to aircraft systems, such as avionics, flight controls, utilities, sensors, communication, etc., but definitely not limited to this alone. In addition, not only we look for projects and proposals in this area, but we also fund different kinds of we help in setting up facilities also in the educational institutes for kind of design, testing, and validation of facilities for testing and validation of aircraft systems. We also fund projects in systems engineering, flight testing and evaluation, anything related to software, aviation medicine, bioengineering, physiology, human-man interface, HMI that is, and many others, as you'll see in the coming slides. This just to give a brief on what the panel comprises of. We have people from DRDO, we have people from different kinds of educational institutes, IITs, some other universities as well, and there are people from DRDO of different labs which come under the aerospace cluster. So here I would like to bring out the kind of work which is going on so that it will help the university to see what their interests are and how here I'll bring out what is of interest to DRDO. So that there is some kind of a synergy between these two aspects. Can I? Okay. So we have a lab called the Aeronautical Development Establishment, which is in Bangalore, and it works totally on unmanned vehicles, unmanned aerial vehicles, UAVs, and the emphasis is on the flight control systems and developing flight simulators. Then we have Aerial Delivery Research and Development Establishment at Agra, which actually kind of develops balloons, tethered balloons, and aerostats, and parachutes, those kind of things they are developing in ADRDE, and heavy drop systems and aircraft arrest barrier systems. Then we have Center for Airborne Systems, from where I come from. I actually superannuated from there. And we have actually developed this airborne early warning and control system, making India like the 5th in the world to have such a airborne early warning and control system. So there we develop systems for airborne surveillance, maritime surveillance, intelligence, target acquisition and reconnaissance systems are being developed, both for, we do both maritime surveillance as well as aerial surveillance. So it's a very complex project, and we have delivered such systems to the Indian Air Force, and in fact it's being operationally utilized to a large extent. Then we have the Gas Turbine Research Establishment, which is also in Bangalore, which works on the engines and the derivatives. Then we have Defense Metallurgical Research Lab in Hyderabad, which works on aerospace materials. And then we have at Kanpur DMSRD, which works on stealth materials, non-metallic materials. And then we have missile labs also, DRDL, RCI, ASL, Advanced Systems Lab, then Research Center Imarat, and the Defense Research and Development Lab, which works on different types of missile systems, and the technologies works on different types of propulsion systems, avionics systems, seekers, and then there is R&D engineers which works on composite technologies in Pune. We have a very electronics research and development lab also in Bangalore, which works on radars. Basically, it works on both communication systems, radars, and all the related technologies. There's another lab, DLRL, which works on EW system, electronic warfare systems, both in terms of communication as well as in terms of RF. So, and then we have the special program lab which deals with the space technologies. In addition to these DRDO labs, we also, in the umbrella of the ARDB, we have both CSIR lab, NAL, National Aerospace Lab, and ISRO labs. So the thrust areas which are of interest to ARDB are aircraft health management, where we want to see how the engine health is, and there is a kind of all kinds of hardware mapping is done to find out as and when the system is operational, periodically check its health. Then on electric propulsion, everyone's moving towards electric propulsion, stealth technology, that is to make more and more your aircrafts invisible to the enemy, both in terms of radio frequency, in terms of oral, that is voice, in terms of thermal camouflaging. These are the different techniques on which we are interested in. Space defense technologies, materials, then the design and development of transport aircraft, space missions, HMI, that is the human man-machine engineering, how to do that. The cyber-physical systems, quantum computing, of course, there is a huge amount of work going on in that, and we have a special young scientist lab working on quantum computing, and also another young scientist lab working on AI and machine learning. Now, all these areas of interest get mapped to different types of programs which are being developed as a system, as a whole. Like you have the LC, of course, everyone would be knowing about the light combat aircraft, Tejas. In addition, we have the advanced medium combat aircraft and an unmanned UCAV, that is unmanned combat aerial vehicle. So these are all these areas of interest gets mapped to some of the programs being developed, designed and developed by different labs of DRDO. So like the airborne surveillance systems, of course, the CABS is doing that. There's also the work on the airborne ISTAR. ISTAR means you look at the airborne intelligence surveillance. Okay. Why is this coming here? Oh, can I just, no. Okay. Yeah. So this ISTAR is another, it's like a mission aircraft where the capabilities for doing airborne intelligence gathering, surveillance, targeting, and reconnaissance is completely, it's a new aircraft which is born with these features with a lot of mission systems on board. Then we have missile programs where these technologies can be used, helicopters. Then we have the UAVs being developed by ADE, Nishant, Rustam, and so on. And the NAL is developing the Hansa and the Saras aircraft and space vehicles. So a little more description about what we are looking at in these thrust areas is like we have autonomous systems and drones, where we feel when we are talking of autonomous systems and drones, as and when there's a swarm of drones, the communication part of it, how fast the data gets transferred between each of the drones, that part of it probably with 6G it should be much faster, taking into consideration the security features, the latency, and the rates. So this autonomous systems and drones is one, space systems engineering is another one, and then AI and machine learning is used extensively for battlefield management, control and intelligently control the autonomous weapons, and to make faster decisions so that very, very strategic decisions can be made using these systems. Another area is multi-sensor data fusion. So as what we see is we have so many sensors on board. We have different kinds of radars on board, and then we have thermal imaging cameras, we have daylight cameras, we have IR cameras. So the image fusion, which happens using AI, to give a much better location of all the targets which are there in space. So that gets coordinated very well by using this multi-sensor data fusion, using AI and machine learning techniques. Then, as I told you, in DLRL, the lab works on EW, electronic warfare systems. So you have a lot of communication happening between two aircrafts, or it could be from aircraft to ground, and they can be intercepted. And you, as when you are flying on the border, you would like to also know what kind of communication happening on the border on the other side. So for that, you need to do natural language processing, intelligently analyze the data, and try to detect the threat. Using AI, it's possible. Then the aircraft is such a complex system, how to maintain it. And every time you find a fault, the aircraft gets grounded, which is not what you want. So you should be prepared to predict the problems in advance and have it serviced much before the actual mission is to be performed. And of course, we know that cybersecurity and threat detection is very important, and we should protect ourselves. Our communication systems should not be intercepted and analyzed by the enemy, so we need to have the security features implemented in us. Then we have to, suppose you want to do a mission, you have to optimize your mission. I mean, you have to, suppose you have made a aircraft, missionized aircraft for surveillance, then you don't want to fly every time for, seeing whether the sensors are performing as they are supposed to. So you want to optimize each one of those sorties. For that, you again need AI to plan and take minimum number of sorties or the optimized number of sorties and see whether the entire functionality of the sensor is met in that area. So you need to have a real-time data integration and adaptive planning. So that again is very useful. Then of course we use quantum computers for quantum computation. What happens is mission planning will have many, many kinds of missions, and you need to cover the entire, suppose we say a radar is going to cover 120 degrees or so. So you should see that anything which is coming within this 120 degrees coverage at a range of some X kilometers, you should be able to see that your radar is performing is able to detect targets with the given probability of detection. So those kind of planning, mission planning, when you do, it becomes a very, very large scale algorithm, and it becomes very computationally extensive. So you need to use quantum computation to do that. And of course you can, for communication channels, you can use quantum cryptography, which is what we are working on. And now the quantum radars, actually the Chinese have already developed it, although the ranges are much lesser. But quantum radars help in giving you a much better detection, much better sensitivity, and they are less vulnerable to any kind of interception. And stealth and anti-stealth I already talked about, and model-based system engineering. So a little fast, I hope I have enough time. Yeah. So systems engineering, basically I'll just give a little broad view of what systems engineering is. So system engineering, if we look, like I said, for any airborne early warning and control system, there are multiple sensors on board, okay. And then inside also there are many operators sitting, and the complete picture of what the sensors are seeing is displayed to the operators. It's a very complex system. So system engineering approach is followed for any kind of complex system. In case of, even if you look at 6G, you will have multiple unmanned, manned vehicles on the, which may be at a different height. There may be ground stations, there may be soldiers, there may be command and control centers, and it becomes a very complex system. For such complex systems, it's very important to use system engineering because it helps you to define, develop, and deploy in such a manner right from its inception to the I mean, we say from birth to burial. So that's how the system engineering helps to, it helps you to design and develop a system which is of high quality and cost effective. So it takes kind of a top-down approach. So what happens is, and it looks at the system as a whole. It doesn't immediately, break it down or part by part, no. It looks at the system as a whole. It uses an iterative process from top to bottom and ensures that you meet the system requirements in an optimal manner. And if you look at any such system, whether it's an aircraft or even 6G, it is a multidisciplinary system. It has fields like electronics, thermal, managing heat, so thermal management. Then you have, if you're looking at form of drones, how the atmosphere is going to affect the communication. So those kind of different kinds of disciplines. So it's transdisciplinary and integrative approach for successful realization, use, and retirement of the system. So it follows something called as a what is called as a V model. So V model is you start with what you want to build. You define what you want to build, and on the other end of the V, you kind of integrate and verify whether whatever you wanted to build, has it been built or not. So from the concept of operation, that is the user, whoever is the customer or the user will define your concept of operation and give you the requirements. Once you have the requirements, you try to analyze them and define an architecture. That is how the system is interacting externally, how it will interact internally. Followed, after that, you will kind of break it up into its subsystems and then design the components. Either you procure and fabricate and assemble it, then you integrate all of that, then you verify, and finally the user will validate that whether whatever they have asked, has it been met or not. So that's what, it's so complex that it has multiple, blocks or something, like you define, analyze, design, implement, and as and when you're doing, the user will come and say, okay, no, this is not what I want. He'll change the requirement. How it influences the other, how it influences the design, you need to see that. So the configuration management, how do you do? So once everything falls in place, you get a operational excellence system. This is what I'm trying to bring out. Here, this is a system hierarchy. So when you, these are the steps which we follow in systems engineering. That is, you have a system, say you have an mission aircraft. You will divide it into, say you will have an airborne segment, you will have a ground segment. And then so on and so forth. In the airborne segment, you will have a radar system, you will have EW system, you will have a display, so on and so forth. Finally, you will go to the last part of it, which can be just separated and identified as a single element. So this is how you break it up, and then you define the architecture, that how these elements and subsystems will be, and then you allocate different types of functions to each one of them. And then you define that how they are going to interact with each other. We call them as interfaces. So you define the interface requirements, both how it's going to interact externally and internally. And you take, during defining the system architecture, you need to take important decisions on what are the trade-offs. Why did you choose this particular way of building the system? What are the pros and cons? So you will have to take all the trade-offs and assumptions and then take strategic decisions. And the type of requirements could be like operational requirements, which are given by the user. Then functional requirements are what is given, what has to be done. Performance is how well it has to be done. And that has to be defined for each of the functions. And the derived requirements are like, suppose you have an aircraft which is flying at 20,000 or 25,000 feet. And you have a requirement saying that whatever information is gathered from the top, and seeing what is the air situation pictures, what are the targets around, which of them are our friendly targets, which are enemy targets, that information has to be communicated to the ground system. So when you have to do that, that is the main requirement. And then the derived requirement would be that your communication system should have those technical, should be technically qualified to meet that requirement. Say it has to transmit the data from, say, 20,000 feet to a ground station, I mean, say about 300 kilometers or so. So that part, your communication system which is sitting on board should have the capability to transmit to that range without any loss of data and at the required speed. So now coming to the 6G requirements. So here we all know that now as and when your data requirements are increasing, the number of communication, whatever is in the sky, is in the air or is on the ground, everything has to get connected. So you need to have higher data rates. So you need to have terabytes of data rates. So for that, is one of the requirements of 6G. I'm sure all of you know these things, but I'm just linking up the system engineering to 6G key requirements. So then it should have, as the number of elements or the devices which are used in 6G are increasing, whether it's in, whether it is for automated vehicles or whether it is in a manufacturing industry, everywhere the number of elements are increasing, so we should be able to, 6G should be able to have higher connection density to support this kind of increased demands of connected devices. And of course, when we talk of military, we need that it should be robust. It should not, it should be robust means it should not fail. It should be reliable. And it should be secure. Our information, when we are communicating from one point to another point, it should be secured. That's very important for military as well as for other civilian applications as well. Then, now we are looking everywhere about sustainability. So whatever we are kind of using, the components which we are using in the design of 6G, there should be there should be a reduction in the energy consumption per bit. So we should use kind of fully recyclable components, and even like it, you can use the solar panels, and though the 6G elements can use the solar panels which are situated nearby, store that energy in the form of in the battery, and then it becomes a green energy. And another major requirement is that there are many places where we don't get signals, so you would like to have ubiquitous 3D coverage. That is, wherever there are some dead spots because of whatever reasons, could be because of you know, tall buildings or some other reasons. So the connectivity should be all through, everywhere, 360 degrees in all the dimensions, and it should be both in land, sea, and space. So these are the performance indices. Like I said, in system requirements, we need to have functional requirements, and these are the performance requirements, like the peak data rates. As compared to 5G now, 6G has 1 terabits per second. Then latency is reduced to almost 1 millisecond as compared to 10 milliseconds in 5G. The error rates are 10 to the power minus 9 in 6G. Efficiency is 1 picojoules per bit. And mobility, like we have tanks which are mobile, or even if you talk of autonomous vehicles, Now it is able to provide communication up to a speed of 1,000 kilometers per hour, and it also integrates fully with the satellites. So these are the elements which I'm just showing here, the figure of, you know, kind of an architecture of a 4G or a 5G network, where you have the radio access network and the core. And here you can see in the radio access network, you have various base stations, towers, and autonomous vehicles, whereas you have all the gateways or the servers in the core. So the elements of 6G, here I'm trying to describe the architecture of 6G. You have the core network, where you have an infrastructure comprising of actual servers, centralized servers that handle the data. And you also, the AI-powered data processing units can be part of the core network. Then you have edge computing network, which is again edge servers, which are very close to the users. They also, these are very close to the users, so that you have very low latency data processing and kind of distribute the load between the core and the edge. Then we have the connectivity layers, which are coming from drones, satellites, balloons, etc., or cell towers and micro and small cells. Then we have the user equipment, like smartphones, IoT devices, here autonomous vehicles and drones, and wearable technology like smartwatches, etc. And then we need to have processing capability to ensure security by encryption, using quantum encryption technology, and then display the whole thing in the form of holographic communication. Then you have data flow and connectivity happens using high-speed signal lines. And then suppose we need very high reliability, like in the case of autonomous vehicles, you have the ultra-reliable low-latency communication. And coming to the use cases for military. So you have a UAV, which you have a UAV or a manned aircraft which needs to communicate to the autonomous vehicles and logistics. So you can use 6G over there, so that these autonomous vehicles can move to strategically move to the location, so as to defend themselves as well as to take care of the threats which are incoming. It can also be used for training the soldiers both on the ground, as well as it can be used for training the pilots across different kind of locations. So for that you need to have 6G communication. So suppose there are some naval ships, and at one location, maybe in Cochin, and then you have in Delhi the command and control center, and then we have the Air Force base at Agra. So how all these, and army at some other place, so how all these three should coordinate in a warlike scenario, so that and the people who are going to take care of all this situation be trained at one place can happen only using 6G. Similarly, 6G can be used for intelligence, surveillance, and reconnaissance. You get much better location finding by using 6G. You can actually locate threat targets very with an accuracy of almost centimeters. And then you can have this AI augmented and virtual reality displays. Basically what happens is all this information comes to a command and control center, which may be located on the ground, mostly located on the ground, and that will help the commanders to decide what next to do. So these are again some possible military use cases. So I'm just going to bring out to you how communication happens in most airborne systems. So we have different kinds of airborne early warning and control systems which are flying maybe on eastern and western borders, and then they are collecting the information about what's happening across the border. And then in addition, we have the fighter aircrafts, then we have other aircrafts which are flying, and then each one of them communicate to each other, and whatever information they have gathered, it goes to the respective ground stations which are in their line of sight. Okay, so from the ground station, it goes to the integrated air command and control center, and that integrated air command and control center also gathers information from other radars like coastal radars and other radars on the borders, and that information is kind of collated and sent to the centralized command where the commander, overall chief, is sitting and seeing the complete picture. So this is how communication is happening right now. It's not using 6G at all in defense. Right now we're not using, because it is point-to-point communication, or it could be through the satellite. So this is what I'm trying to depict the network-centric warfare scenario, where you have all kinds of ground station towers, then you have tethered balloons, stratostrophic balloons, and then these are maybe like 1 kilometer, 10 kilometer, 30 kilometer. What are the kind of systems which are there at different heights? So when all these systems are flying, now that was on the air. In addition, we have submarines and sonobuoys which are underwater, and then we have naval ships which are again in the sea. So all this information is going to the coalition headquarters, as you can see over here, and it helps to kind of take strategic decisions, and it helps the commander to steer the forces of different types which are located at different places in a proper way so as to win the war. So I would like to conclude by saying that very important for aerospace and defense and DRDO to use 6G, especially with the kind of capabilities it has. And so these are some of the things what we would like to explore for military. So that's the need of the hour. That is, we need to implement 6G for aerospace and defense, but following the system engineering principles. Thank you very much. I said Jai Hind, yes.
Any question, any query, any suggestion? We can interact, we can take 1 or 2 questions. Yeah.
Okay, I'll just make a little comment.
Thank
Madam,
you.
Wonderful presentation. I just want to, it's not related to this, but I saw that you mentioned for sustainability, we need to reduce, for sustainability, we need to reduce energy consumption per bit. And as a physicist, I remembered that just is a definition of temperature if we measure entropy in bits. So we are trying to reduce temperature here of some sort. So that is a very curious thing. In information theory, for example, entropy is measured in bits, and energy per bit is like temperature. So when we are saying we have to reduce energy consumption per bit, we are talking about reducing some kind of temperature. So that has something clicked to me. But otherwise, just wanted to mention that. It's a wonderful presentation, madam, very informative and very to the point.
Thank you for your input. Very good thing. Yeah, madam, please carry on.
Yes. Thank you so much, ma'am, for your valuable insights. We'll be now having a tea break for 15 minutes, and we'll join back for panel discussions just after tea. Thank you.
CTIF Global Capsule Ceremony with a cake cutting, and then we'll proceed with the remaining panel discussions. Request to all the participants, guests, to assemble back in the auditorium, please.
Good evening, everyone. I warmly welcome you all to the 20-year celebration ceremony of CTIF Global Capsule, CGC. CGC was founded in 2004 by Professor Ramji Prasad as CTIF, Center for Tele-Infrastructure at Aalborg University. It worked as cross-interdisciplinary academic research center until 2014. From 2015 to 2017, CGC had operated from University Tor Vergata in Rome, Italy. After this tenure, CGC moved to Aarhus University in 2017 and worked until the middle of 2023. In 2023, CGC was renamed as Core Tele Infrastructure Global Capsule and had attained its stature as a collaborative, interdisciplinary, independent and non-profit organization with a robust network of research, academia, and industry. I will now take this opportunity to invite the young visionary man behind CTIF Global Capsule, Professor Ramji Prasad, for the welcome and celebratory address. A great round of applause for Professor Ramji Prasad.
I asked one simple question to the Vice Chancellor of Sharda University. Shall I say good evening or good afternoon? First, he mentioned that I should say good evening. And then I was walking like this, then he called me again. Sir, it is not good night, good afternoon. Okay. So I repeat good morning, good, because you know, globe is very big. Somewhere it is good morning, somewhere it is good afternoon, somewhere it is a good evening, somewhere it may be good night also. CTIF Global Capsule, it is a global organization, so I should not say only good afternoon. So I mentioned all aspects. Purnima already mentioned to briefly about CTIF. Purnima, what do you expect from me? Where is she? What do you expect from me to talk?
Celebratory address. Talk about CTIF and CGC and your journey. Whatever you feel like it, you can talk. It's an address.
Okay. You have mentioned that when it was launched, did you say that? 2004. Okay. It is the 20-year celebration, so naturally it was launched in 2004 at Aalborg University, Denmark. And I still remember the face of the people. That time, president of Aalborg University was Kasper. Am I correct, Peter? Kasper was the president of the university. And Finn Kjærsdam was the dean that time. Yeah. So just, I'm going to the past, remembering the faces of the people who were present at the opening of CTIF. And still I remember, it was very stormy day and heavy snowfall all over Europe. I had invited Commissioner of European Union to open the CTIF. His secretary called me, Professor Prasad, Commissioner is in the flight. Then she called me, still he is in the flight. After 1 hour she called me, flight is cancelled because of the weather. Then I said, send his lecture. He must have prepared the lecture. She faxed, those time it was faxed, so she faxed that text of his lecture. And I think Shingo Omori, you were there at the opening, if I am correct, Dr. Omori, you were present. So at the opening, at least one person is present here from Japan, and he was witness of the opening of CTIF Global Capsule. Then I thought I should not read the text of the commissioner, somebody else should read the text of the commissioner. And Peter, perhaps I asked the Finn Kjærsdam. Am I correct? So Dean of the Faculty of Engineering, Finn Kjærsdam, I requested him to read the lecture of the commissioner, you know, what I'm calling you Commissioner of European Union, just like Central Government Minister of Government of India. Finn Kjærsdam said, Ramji, do you think I'm appropriate to read it? I said, if you cannot read it, then I'm also not appropriate then in that case. He said, no, you are the host, you should read it. I refused. I think finally Finn agreed to read the text of the commissioner. It appeared in the newspaper, and the reporter did the very mistake. He took the photo of Finn, newspaper appeared with the photo of Finn, Commissioner of European Union. And then Finn called me, what did you do? I said, I didn't do anything. You gave the talk as a Commissioner of European Union, and press reporter put your photo as the Commissioner of European Union. Nothing wrong, don't worry. One day you will be Commissioner. He said, no, I don't want to go into politics. I'm an academician. I would like to become the dean. I would like to become the president of university, but not beyond that. And just you will be surprised, within a month he became the president of Aalborg University. And that was a great news for all of us. He was a real academician and a real intellectual. And till he was the rector of the, or president of the Aalborg University, he gave us the full freedom to grow. And he said, Ramji, go ahead, make it global. First it was called CTIF, Center for Tele-Infrastructure. And then he said, Ramji, make it global. I changed the name. I made it CTIF Global Capsule. Capsule I added only because, still I remember when I was a young boy, 5 years old, my sister got sick, and that time it was typhoid, was a very serious disease. And doctor told my father, she cannot survive until you get this medicine. And those days that medicine was not available in India. He managed to get it from the UK. And only I heard a word from my father, it is a capsule. So capsule can remove the disease that time. My sister got rid of the typhoid, and she survived for a long, long time. I thought for the telecommunication, I can set up something which is capsule, which can remove the problem of the world. And therefore, I called it CTIF Global Capsule. This is the brief history of CTIF Global Capsule. So CTIF Global Capsule grew. It was center of tele-infrastructure. It was perhaps 2013, am I right, Peter? I am asking every question to him because he is my vice president. And vice president is always smarter than the president. Am I right, Peter? So, he was with me, and I remember. I had invited him for dinner, and I forgot. About 8 o'clock, he told me, where is dinner? I said, just finish the meeting, go for dinner. He said, no, you invited me for dinner. And 8 o'clock evening, I told him, look, if I call my wife to prepare dinner for 2 persons, she will divorce me. What do you want, divorce or dinner? He said, definitely I don't want you to divorce, but definitely I would like to have dinner. In my office, always I used to have pistachio, and good amount of pistachio, at minimum 1 kilo available. And pistachio from California. My daughter, whenever she used to come to Denmark, still she is doing that. My daughter is here somewhere. Here, she is there. She used to bring pistachio. And half of the pistachio, nearly, listen, half of the pistachio is always eaten by Peter. So that evening, I said, enjoy pistachio. And as a courtesy Indian diplomacy, I was doing like this, every pistachio I was giving him. After giving 25 pistachio, I thought he must be satisfied. Peter, dinner is over. Are you okay? He knew that Ramji will not give me more than this. He said, I am satisfied, I am not hungry. I will not ask my wife to prepare dinner anymore. So, this is the, and then during the pistachio business, we discussed it should not be center. It is a global organization. Center is just one place. So we should change the name. And then now we call it Core Tele-Infrastructure. Peter, am I right? He has become Indian. You know, Indian, if you ask, is it right? They will say, it is wrong. So you can see that he does not say yes or no. He does like this or does like this. ठीक है. He knows Hindi also. ठीक है. So it means my statement is correct. So Core Tele-Infrastructure, it is the name of the CTIF now. Core Tele-Infrastructure Global, CTIF Global is capsule. And Peter should correct me. I think we have more than 18 divisions of CTIF Global Capsule all over the world. To my memory, we have one or two. How many divisions we have in India? 3. So we have 3 divisions in India. And Mr. Vice Chancellor, oh, I have to call Sibaram. See, I called him Mr. Vice Chancellor, he didn't listen to me. As soon as I called him, Sibaram, can you come here, please? Can you say few words in positive direction that your university may become part of CTIF Global Capsule, or you would like to open the office of CTIF Global Capsule at Sharda University, please?
So today, very interesting story we have heard from you, sir. The capsule word you coined, CTIF, not only capsule, it is not intercontinental European capsule or Indian capsule, it is a global capsule.
Right.
So you did not coin also the name vaccine. So very rightfully, because vaccine we take to protect ourselves, already we have something, we preserve body. But here rightfully the capsule is required to cure some disease. And you have not used the steroid also, not the tablet, because capsule is very serious and important drugs which is required to cure some of the serious diseases, lacuna. Whole education system, all worldwide, they are suffering from a very severe disease. That is the entrepreneurship. Because in academic institutions, we always confine mostly in the classrooms, the raw delivery, some kinds of laboratories are there. They are all very usual, not having any industry sense mostly. And some of the cutting edge research also going on. But again, you research and that research outcomes, whatever is coming out in the form of IPR again you have to convert into the products, and then it is actually going to the market and you become entrepreneur, which is the sole purpose of the education. So education's knowledge you are acquiring, and in the form of products or service, you are giving back to the society. So completing the sense of actual educations we are getting. This capsule is much more needed in India, because now Government of India has told the Make in India, Startup India, Digital India, Self-Reliant India, and now they have declared that Viksit Bharat, that is Develop India by 2047. So our countdown has started already by 2047, 15th August, how many hours and days are left. So that countdown clock is already started. But educations and applied educations, how to engage the students specifically in the higher education system, how they can think and how we can trigger their knowledge that meaningful applied learning will be there, and students can take up some of the incubation or startup approach to come out with some of the products and establishing the companies, becoming entrepreneur. That multiplies the economy, actual applied knowledge, and a whole country will be evolving, because you are giving not only the economic growth, but you are providing some solutions which is required by the community, by the society, by some of the advancement, infrastructure development and services in the IT sector and in other sectors. And also making the human life comfortable, easy, and progressive, and giving a lot of security in all domains. As you know that India is agro-based, but India is not lagging also in IT. But only thing is that in manufacturing sectors, there is a lot of works have to be done. In Indian education system, 30% students are hosted by government institutes, and private organizations are taking the stake of 75% of the ecosystem. And India, we have 50,000 around higher education institutions. So you can imagine that almost 44 million students are there in the higher education system. And India is having the world's largest higher education system, because having around 50,000 and then 1,200 universities and 44 million students at any instant of time in the higher educations. But only thing is that India needs this capsule, because every day and night we are trying, but how to engage the students. And basically, there is a lot of scopes. I have learned from the Peter Lindgren that there is a need to engage the students to make them learn that how they will actually have any knowledge and apply and take it forward to become entrepreneur. And this medicine shop, you have only 3 in India. Hopefully, I will praise also, you said that today this is the need of the hour. And people are thinking very aggressively that how entrepreneurship-based learning can be there, how industry can be integrated in the higher education system. And you thought it before 20 years and established the CDC and thereby CTIF, Global Capsule. And you also established wireless personal multimedia communications, where people just coined the word, very few scientists, the multimedia. And, but that topic, CTIF or CDC and WPMC, after these many years, becoming more relevant. So, your visionary, sir, and your contributions to the communications and noble thoughts that you want to give back to the society and to the world as a whole, and your idea that people should adopt and should take interest, not for your benefit of the economic benefit, but for the benefit of the students and for any country to grow. Because job opportunities can be created only by entrepreneurship, and it has multiple advantages and chain effects also always. So that's why I admire, and as a Vice Chancellor, I promise that already we have established that center. So you can open your 4th CTIF center. It is already opened. I have told him that he should keep all the materials here and lock it and go. Then we'll further discuss that how we can take these ventures without disturbing. So you have made a good setup. We have found the place, and I thank WPMC that with the initiative that we need to fulfill the requirement to conduct your sessions, we could prepare a lab, and that will remain permanent. So I wish you all the best. Thank you very much, sir. Your noble idea and your visionary ideas, now it is becoming still modern, and we need to take it forward to contribute towards India and as a global. Thank you very much.
Now this is the cake cutting time. So cake will be cutting for two purposes. One is 20 years celebration of CTIF Global Capsule, and the second is establishing CTIF Global Capsule at Sharda University.
Yes.
Only one cake for two purposes. Okay, Peter. No, let me call. Don't worry. Peter, please say a few good words, and don't abuse me.
So, thank you very much. So, I already said some at the welcome session here, and thanks to everybody about letting me have the opportunity to just say a little bit about the CTIF Global Capsule. So, as you can see, it has been a long story, 20 years, and I have not been in that story all the time, but nearly. And as I said at the welcome speech, I heard about a famous professor, Ramdi Prasad, that was doing some very, very interesting things in wireless technology back in 2003. And as I said, I had a dream to meet him, and you can also hear from his speech that sometimes these meetings comes out in a different way when you come and you hope that you will have a big lunch with everything, and then you just have pistachio nuts. But the pistachio nuts was, once I got the first one, I got my body was, banging and so on, because it was actually saying that this is something that I should pay attention to and work with for the rest of my life. And sometimes my wife, she asked me, why are you working with CTIF Global Capsule? And I say, I can't help it. It's just like a virus. You just want to do it. And as Ramdi said, it was your sister got the medicine and the capsule, and she recovered. I have felt the same with my researchers in CTIF Global Capsule together with Ramdi, that once they taste the CTIF Global Capsule, then they will never forget about it, and they will always work with us. It is true that we formulated a strategy under a pistachio nut meeting in 2013, and just before that, Ramdi didn't mention that much, but I actually had another large center called ICEI, about 10 million euros center, where we were focusing on business models. And what you see today down at the first floor is young students from Sharda University and from NTU working on a business model challenge on a Danish business. And we have had, I think we had 7 or 8 visitors from different universities today. We had yesterday also other people that looked into that this is a different way of teaching and learning the students. They have the business models in their hands, they feel it. So in 2015, we started up in Rome, as I said at the welcome speech, at Villa Mondragone, and a little bit later we moved on to Aarhus University, And through that process, we got some of the largest European projects. I sometimes have calculated how much money we have actually generated through funding. And I think it's at least 250, 300 million while I was involved with Remedy on this. And before that, Remedy has actually generated some of the largest projects in EU, Magnet Beyond, and so on. And nearly knows everything about it. So now, as I said, we had a strong push from our network partners, divisions, to move the head office out of a university, in this case Aarhus University, and we moved it to Skagen and made it into a firstly a private limit CDC holding. And today we are standing here 2024, and we are establishing CDC IDL here in Delhi. And thanks to Punima Lala that introduced me here. I can't see her right now. Oh, you're in the back? Okay. I want to thank you very much, Punima, for making it happen here in Delhi. And I don't know how many have noticed it, but yesterday she actually had a birthday, and I was stuck in the Delhi traffic due to that we don't have 6G yet, but we'll soon have in 2030. So I bought a little present, and it's a little late, so please. Should I join? Yeah, it's actually a special, in Danish we call it peberkværn. You can translate it, so you can have a pistache nut in it, and then it can crush it and put it over your dinner. Sorry? Yes. Okay, but our aim is not just to have CDC IDL open here. We are trying, as our strategy says, we're trying to create a CDC foundation, and it will be a non-profit foundation. And the two businesses, CDC Holding and CDC IDL, will be under this umbrella. As Remedy said, we have 18 universities that are a division of us. Our goal is in 2025 to have 25. So we are very close to this. Another thing that we want to do is we want not just to have them to live alone, the division, we want to connect them. We want to make experiments, labs. We want to make more large projects. We know research needs money. And that was actually the first thing I said to Remedy when I met him in 2005. Not just on the 2005 meeting, a little bit later after when I dared to say it. Remedy, you are producing in this network fantastic technology. Can I be allowed to have a look into it and see if we can do business models on top of it? And this, I think this connection, we complement each other. Another thing that we are definitely going to do is that CDC South America, Brazil, we have tried to, I have at least tried to come to Brazil this year. It didn't happen, sorry about that, Paulo. But we are going to work very, very hard to open in South America and firstly on Brazil. And thank you for doing fantastic work in South America. We are also going to establish a more advanced lab in Denmark. But not just in Denmark, we want to have them all over the places that we have division. So now we are looking forward to 2030, and in 2030 we will have 6G. That's what we have heard on the conference many times, everybody has promised that we will have 6G in 2030. So how will 6G, how will it look in 2030? Well, I guess we will have 6G, we will have AI and advanced sensors embedded in it in all our business models. But I guess most of the researchers will then start to work on RAM-G. And I think this is going to be fantastic because, as Remy he has said many times, most of us will be 120, 125, and the 6G will give us a possibility, some possibilities that we have never imagined. Space will be included. We will have a much larger business model ecosystem to do our business models in. So I can only say I'm looking very, very much forward to the next coming years. And I thank you very much for letting us open and celebrate our CETIF Global Capsule, as you can see here on this nice slide here. All the journey, and I'm very proud to work on CDC. I invite everybody to join so we can make it stronger in the future. Thank you very much.
Thank you, Professor Peter, for your kind address and a nice birthday gift for me. Thank you so much. Now we will move on to the cake cutting ceremony. Can we have the cake, please? May I please invite Dr. Omori, because he was there when the first CGC was established in 2004. Dr. Shingo Omori, can we please have you on the stage? Thank you so much, all the dignitaries, and thank you so much, everyone, for being here and celebrating this occasion with us. It means a lot to us. And now we'll continue with the panel discussion. You may please have the cake along with the tea and coffee just outside the hall at 4th floor only. Thank you so much.
Thank you, Purnima. Congratulations, Professor Ramji, Professor Peter, and other members of CTIF on 20th anniversary of CGC. We are delighted that the 20th anniversary of CGC is celebrated in Sharda campus. Ladies and gentlemen, as we navigate through the profound impact of technology on various facets of our lives, it is equally vital to explore its potential in addressing societal challenges. The intersection of technology, human behavior, and policy offers unprecedented opportunities to address critical challenges. We, as academicians and researchers, have this responsibility to ensure that the cognitive skills of our students are built parallelly to AI to ensure a sustainable society and sustainable education. We now move to an exciting panel discussion titled as Milescaped Adaptive Architecture, Empowering Human-Centered Learning Beyond 2050 with AI, Secure 6G, and Sustainable Education. I invite the panelists of this session on the stage, Mr. Vivek Ahuja. He is an architect by profession and a consultant. And we have Professor Ramji Prasad. We have been listening to Sir on various occasions, on various topics on this stage. So introducing him on this stage would be like showing light to sun. Sir, we welcome you on the stage and to start with the panel discussion.
Okay, I just taken this topic, Mind-Sculpt Adaptive Architecture. It's about, empowering, human-centered learning beyond 2050 with AI and secure 6G and sustainable educations. So we have just tried to create the bond with the, where the technology is going to advance and how we can create the bond and still, educate the students and increase their cognitive skills. Mind-Sculpt architecture is about creating a framework. Okay, this framework is designed to prepare the individuals to seamlessly integrate the emerging technologies in their lifestyles, because this technology is moving very fast. Okay, and you're saying by 2030, 6G will also be there. So with this time, we have to increase the cognitive skills of the students also. Along with that, how we can do that? This paper is talk about this. So it's talk about, how to integrate theoretical knowledge, personal experience, because every student is going to have their different experience. So when you combine the experience and the knowledge what he is getting, and along with the sensories and engagements, different products can come up, and different solutions can come up. So we can do this, and that will increase the cognitive skills of the students and human beings. So technologies like AI, ML, 6G, robotics, and simulators, we are going to integrate and create a lab which bridge the gaps between the theory and the practice in education, fostering the deep comprehension and adaptability. I will come to this, how are we going to achieve this. So this is a transformative, journey, and where IoT is going to, combine all the products are going to link, and different kind of exploration can happen. So when this technologies is in place, numerous user interface going to come up, because all the machines are going to be linked, all the products are going to be linked. So that requires the humans of all age, from the the child till the old age person. Everybody has to learn. They have to adapt. How we can do this? So this is the educational framework we are talking about. What we are talking about here, to changing the role of the educator. So educator is not just a teacher, it would be a mentor. And mentor as a human on the top, okay, he created the topics. He used the AI data and analytical tools, okay. and it gives the problems to the students. Students also equipped with this AI, and he will come with some kind of solutions or some kind of response, which mentor is monitoring parallelly. So he can always give some suggestion during the time that this is something you have to change, or this is something you can think of. So all the data is coming to him, and parallelly new things are coming up. So it's a learning for mentor also, it's a learning for student also. But mentor is guiding that, the things don't go in a different direction. It should be positive and result oriented. And then we can use the immersive technologies to train the students, and which is, it will be easy for them to adapt. And finally, the feedback, the performance tracking, that can be done, and mentors knows, okay, this student at certain level, there's always, people are, different skills at different levels, right? So we cannot give evaluate every person on same scales. So in the last stage, when you track the entire student, you understand, okay, this person, this level, these are things to be improved. So he will again put up those things in the AI system, how to improve particular skills to them, and that's how the cognitive skills of the humans is going to increase. What are the tools we can and methodologies we can use over here? So the one possibility is like of creating the learning from the real environment. What we are doing here, for example, we got an archaeological site, right? And we send the student and talk about it. This is the history of this particular, statue or this building, right? Or this mural. We can create a replica of that particular art of finding of archaeological site in the lab itself, and by doing the 3D scanning. And once data is being digitized, then there's a possibilities we can even sometimes if you're digging the site, the artifact is not completed, it's damaged. But once we have digitized it, we can complete the entire thing, and we can make we can easily explain to the students how it was actually at that time when it was built and why it's being built. Then 3D printing is easy to give the final finishing to this. But so this is how it is. The student can take the things in his hand, and they can learn. Okay, this was how it is. So that is, it helps them to learn fast. So as we can use the augmented reality in our structure. Augmented reality is again where you can, is a digital overlay of for example, during the operations, like you get a parallelly digital overlay of what has to do. And you can see the spine structure, where to put your machine exact position. So it is very precise medical services can be done. So one example is being given over here, which is Augmetics X Vision. They developed this spine systems to do the operations. So it can help medical students to learn fast. Another possibility is like about 360-degree storytelling. It's about, say, we can create this whole conference room in kind of, a holographic dome, and you have information happening over here, right, all across, and we can explain what's going on the site. So you can easily visualize this over here itself and talk about the problems. The student can easily immerse into this, and he can express, he can learn the thing fast and express quickly. For example, we can shoot something in rainforest, right? What is happening in rainforest, how the plants are growing, and showing the exact same environment here itself where we are sitting in the conference room. So the student who just know nothing about it, he can feel it. He has his own thoughts, and that is something. The critical thinking is something is required. We cannot have to say, okay, this is you have to do. He can, by seeing the stuff, okay, this is actually is on the site, and what I am supposed to do. That will increase his cognitive skills. Another possibility is about, is about virtual reality, which can help them to understanding the scientific phenomena, and other possibilities, how the process workflows are there. That can easily be understood with this kind of technologies. This is another possibility is like you create the conference or your classroom in the after 2030 or before than that, somebody has to start somewhere. We have all the data when you explaining certain concept, and that the live data is coming, right? So when the mentor is talking about this is how it is, and student can relate, okay, sir, this is the live data, and this is you're talking about that. So he can come up with some new innovative, solutions. So this kind of environment can help the upcoming generation to increase their cognitive skills with the technologies. Another tool is about the computer-generated imaging systems. Now we can, whatever the new imaging system, we can, very closely show. This is the actual, the look and feel of the, for example, the cells of the body or plants. So it will easy to explain to them. So these kind of imagining stuff easy to explain to the students. It gives a faster feedback also. Another tool we are talking about is about simulators. Now, when we say, for example, it's a flight simulator which is already being started, it's already on the place. So you create the actual what is happening in the kind of closed environment, okay? And this entire simulator behave just like you are flying the flight. So the pilot can easily just sit over there, okay? He can learn the things faster. So as this is another possibility about a medical simulator, where this this kid will be shown over here. It will behave just like a human being. So with the technology is going to advance, we can increase the possibilities that this simulator behave exactly, for example, temperature, his pulse rate. So when you're teaching the medicals to the students, okay, you have the simulator along with that. So student can easily see, okay, this is what I'm doing, that's how he's behaving, just in the front of him. So it's easy to understand that, the medical concepts. This is we already on the place, like driving simulators is beyond theirs. Another possibility is about, of creating the industrial simulator. So with industries, 4.0, you have lot of industrial vision going to happen. Now, to understand, to optimize these solutions, if we create the simulators of those factories, right? So we can increase the productivity of those simulators. So this is also going to help to the student to understand, okay, this is the product we are going to make. If we have the similar simulator form of the over here to teach, so he can understand the entire process of creating the products. And that can help to the students, to come up with the new ideas in the future, and what we can do. So he can correlate with the technologies, what's going on right now, and what's supposed to be done in the future. Okay. This can be okay. So once the tools I talk about here, these people are already working on it as of now. The day the 6G and AI, is on the place, okay. So which is making the entire process very efficient, very effective, and widely accessible to everyone. So this is going to be an exciting time coming in the ahead with us. So with the AI integration and then the 6G on the place, the adaptive learning environment, personalized training programs, and real-time feedback is going to come. So once we started up with this kind of structure, the cognitive skills of the human is better to understand, to adapt these technologies faster, and he can still come up with the new things. Another, like, is example that the realism is day by day is improving. So once we're creating the simulators, we can, create the exact environment, what's happening in the space, for example. We can create the similar situation in the room, and it will easy to student to understand that, and he can come with the new solutions. So as augmented reality and virtual reality, that's also going to enhance with the, the speed and the realisms which is going to come up. And once you have the overlay along with that, so student can take the decision. The idea is the critical thinking and the critical decision making, it has to improve, and the human bond also has to be strengthened. We have much talk about this is the digital twins. Okay, the simulator uses digital twins to create the accurate virtual replica of physical systems for better training and optimization. This is, for example, is like you create a factory. A factory is running. Today morning the presentation is happening, right? So the factory is running, and there's a new things which is coming up, right? For example, making the semiconductor chips. And this is very dynamic stuff which is going on. Parallelly, we are creating a digital avatar replica of it, and we are working on that digital stuff, how to improve the system. One team is working on parallelly on it, and parallelly is giving the feedback to the physical system, and physical system is adopting that. They are adopting that. That is the learning to the system and the student also. So this way, we can improve the cognitive skills to the students, and there's a critical thinking. And further, cloud-based simulator that can increase the speed and the accessibility to the remote areas where people don't have the access for this kind of labs. Having said that, we have to also come up with the data acquisition strategies, because data is very important. If we come with data is not correct, a different kind of understanding student going to have. So why not create a system, or we have a team in the institutions who will validate the data to the extent, and institute can also exchange the data among themselves. And this data also can be, come up from the governed or ungoverned systems, which is reliable. This is just an example of maybe, we can create identity to the institutions, that you can come up with a mascot, and that mascot is teaching, and you can, that's where the student can connect with the institute. This is we're talking about that the authenticity of the data is very important, and ethical practice is to be done. So the team which is working in the institutes, it has to see that the data is coming is from proper channel. Secondly, when the data you are giving the data to this lab, and students are utilizing those data to create certain things, how the students are behaving, their identity is to be retained with the institute. It shouldn't go outside. His privacy also has to be maintained. So that's way we can easily adapt these new technologies in the institutes. Further, there is a small guidelines we are trying to create. Is of integrating the emerging technology in the university educations. First is about to establish the clear boundaries, manage the virtual environment usage to prevent the cognitive overload. So every student has different capacity to take the load of the information coming to that. How much one student is grasping, maybe 10%. Another student of same age could be grasping the 50% or 30%, it depends. So depending on the students, we are now capable of, of understanding how much overload of this of information is to be given, or immersive environment has to be created. And we can, easily, we can able to increase the cognitive skills for each and every student rather than just a class. So these opportunities, this coming up with this 6G evolutions and AI, that's a very big opportunity, I think, for the students, for the institutes, and the industries also. This we already talk about for adhering to the ethical standards, because that's required to create the trust and integrity. So all idea is about this entire presentation is about create the to increase develop the critical thinking of the human or the students in all the times, even in the virtual or real environment. So they were able to get the data, have their own thoughts and give the right solutions or answer to that. But his thinking should be on. Further, maybe we have to provide some kind of mental support, because to understand this kind of technologies, immersive technologies, that the support system should be placed in the education system. That it shouldn't be the total over stress to the students while he is in the learning in the immersive environment. So those factors has to also need to be considered. Having said that, this is detached cognition. Is the Sankhya Yoga. This is very old practice in India. Is about getting detached and see all the information, whatever here in real and as well virtual in one times, and keeping yourself away, so that you can understand this is the actual problem is. Once we are into the problem, we're not able to understand what the problem is actually. So once we detach and see the entire data which is coming to you, because at the era of 6G and AI, the huge amount of data is going to come up. Huge amount of data is going to come up. So the students and the people should be capable of understanding that these are the data, and he is not a part of it. And once he starts thinking in that way, he is away from it, he is able to give the right solutions and right understanding of that problem. So this is by this, I just try to create a sustainable living environment and a framework to prepare individuals to thrive into the complex and interconnected world at the era of 6G and AI. So by this, this coming environments, I think new innovations can come up, and I give the prosperous futures to the students, individuals, kids, and the old age people also, because everybody is going to learn with this this new environment which is going to come up in the next 5-10 years time. Thank you very much. This is it. So this is it. Thank you, Ramji sir, also, and thank you, sir, for giving me the opportunity, and thank you, Sharda University. Thank you, sir. Thank you.
Thank you, Mr. Ahuja. Now I invite Professor Ramji Prasad sir for the next session on the theme. Do we have questions? Mr. Vivek Ahuja can take questions related to the theme.
Yes, yeah, the question, yeah.
Yes. So actually, you were a use case for us. Cases. I think everyone they can hear me. This mic is. Oh my goodness, you can hear me now? Okay, so the use case, what you just, first one is the immersive, which you showed. I don't know here, how many of you have really went to a museum, immersive museum? Anyone? Yes? Have you seen Van Gogh art? No. Yes. In San Francisco,
I've been there. It's so nice. You lie down on the floor and you can see actually Van Gogh painting. How do you pronounce in American English, Van Gogh? Van Gogh. Yeah, I'm Dutch, so I pronounce different. So that's what you're talking about.
Yes.
So we need all these requirements.
Okay.
So not technology, but we need your architecture requirement for the details for use case.
Okay, I'll do that. I will do that.
I think he agrees with me there.
Yeah, I'll do that.
I can make him ask a question now.
You know the requirements in many of the research projects that we are participating and the use cases. Yeah. I mean, sometimes, I mean, nobody knows where the requirements come from, or sometimes they are decoupled from reality. And it's really very important, like having, let's say, tangible and realistic use cases and very clear requirements. Then, okay, researchers can, let's say, design systems and provide solutions.
Yeah, right? Definitely we can do that. Once the brief is ready, workflow is there, we can do a lot of things, and we can, make the entire structure in a way that each and every age of persons, a group of persons, will be able to understand this. We can do that, sir.
So, technology is there. We just need the input from you to make it work.
See,
no?
Okay. Okay.
You have? See, now everyone is asking.
It seems to me your outlook is rather pessimistic about 2015. According to Sam Altman from the OpenAI, if AGI will emerge in the next year, what will we do? 6G will appear in 2030. And if AGI will appear in next year, what will you do? What is your thinking about this?
This will open the enormous amount of opportunities to everyone. Everyone is going to have a lot of opportunities going to come once 6G and AI on the place. Like, for example, I'm going back to the things like, okay.
Can we see the presentation?
Okay, can I know how to run this? Okay, to answer to your questions, like I'm saying, this is my opinion. There's huge opportunities to everyone. Everyone going to have a lot of opportunities which coming up where AGI is going to advance and 6G is coming into place. How it is going to happen? For example, like as of now, if you see there's every place you find there's a concrete jungle, we say, because every building is all around, right? Why we have done this? Why done this? Because we know the concrete is going to stay for a long time. We don't have to maintain it, right? We don't have to maintain it. That's why we use the concrete, right? But is it good to stay in the concrete space? Maybe not if you go to science. What is good? To live in the natural environment. But, for example, I stay in a mud house, it requires repairs. It requires repairs too often. How will you get those data that this is decaying? And when this repair is required, somebody has to monitor. But this so many changes going to come. Those data was not possible earlier. With the advancement of 6G and AI, we are able to get those data in real time. Robotics can help maybe to repair the houses, and be able to live in that space. I want to live in the jungle. Why I should live in the house? I want to live in the environment. And what is happening all around with me, okay, those variables, those data, we can collect with the help of 6G and AI in real time. And real time, we can give the solution to that. That's opened the humongous amount of opportunities to the people, how to, solve that problem at that time. Parallelly is giving you the environment, you are the way Earth was being made. So the living is going to be very beautiful when the 6G is going to come in place. It's just about, which direction, the water, we are into, that change the direction. If we change the direction, this directions, I mean, there's humongous opportunities. Space exploration is there. Living in the water, we never explored what's happening in the sea. Because the factor, the variables, which is, are coming over there, we are not able to, capture those data. We are not able to capture the solution to that. Once we are, driving into the sea, we start collecting with the sensing technology going to advance. We're going to collect the data, what's happening over there. We can replicate with the digital twins the data in the lab. We're able to, the student able to say, okay, this is what's happening in the sea. This is the unexplored space. That's the opportunity because the problem is there. We have the data along with us. And we are able to create maybe a kind of, a submarine which can go deeper into the sea, see the environment which haven't explored, what God has made. This is the power of 6G. It's not possible before that. So AGI and 6G, AGI, is going to calculate because the humongous of data has to, conclude faster. So we require that AGI and the AI. And 6G, the network which is going to, is being there, you got us everywhere, right? That's also required to understand that. So this is hardest.
I think we need to work offline and get all your requirements. Okay. Because I think all our, antennas are up here, and we can think of many questions.
A lot of opportunities.
For the,
lot of opportunities.
Thank you so much. Yeah. Thank you so much.
Yeah.
We can have more questions offline. Thank you, Mr. Ahuja, for this enriching discussion and session. Ladies and gentlemen, this has been a day long with intellectual discussions and talks. Our students of Sharda University have prepared some cultural performances filled with fun and entertainment. And we break for 5 minutes so that we get time to prepare the stage. And then our students will perform some entertaining performances showcasing the diversity of India for all of you. Thank you. Your choice, ma'am.
for the entire energy of modern aspirations. It is a country where every sunrise illuminates the sacred Ganges and every sunset casts its golden hues over the tranquil backwaters of Kerala. India is the soil that birthed spiritual wisdom through the Vedas, echoed peace in the teachings of Mahatma Gandhi, and crafted epics like Mahabharata and Ramayana. The stories transcend times and borders. It is a place and art dance together. From the mathematical genius of Aryabhat who discovered zero, India. From the eternal love that is the celestial beauty of Taj Mahal, India. The colors of India are the diverse as its landscapes, from the snow-kissed peaks of Himalayas to the golden sands of Rajasthan. Every corner of this nation is a canvas painted with nature's finest hues. Now when we talk about WPMC, we know it's about technology. How far we are in India when we are talking about technology. I'm really proud to say this thing, that in India, financial year 2023, India got 89.5 billion UPI transactions for FY 2023. You think it's a small number, right? Is it? Well, compared to USA did 2.5 billion transactions only. It is more than 85 billion more transactions in India in the entire 2023 of year, and it is a round of applause for this. We know we celebrate Diwali. Of course, we have our guest, and we say, Vasudhaiva Kutumbakam. The entire world is one family. And India is the family of harmony, culture, tradition. We respect everything that we are building here together. And we are right now sitting in a small India in Sharda University, where more than 95 plus countries, students are residing the entire campus. A very good evening and warm welcome to everyone. We are hosting WPMC 27th edition here at Sharda University. Here, the world meets and celebrates innovation, knowledge, and collaboration. My name is Mirazuddin Khan, and I'm a proud member of Dean Student Welfare, Sharda University, and I'm truly honored to stand before such a distinguished guests, visionaries, leaders, researchers, and students who are here to make this event not just a conference, but a transformer journey. Today, we bring together not just our minds, our technology, our visionaries, our leadership, but the most important thing that we are bringing together is our culture. Our culture is the only thing that binds us together, not just a country, but the entire world. Japan, USA, China, Asia, Europe, America, all the continents are there. But one thing over there, what? The culture. And in India, we celebrate this culture. And in Sharda University, we celebrate the culture, the great culture of the entire India, the small India of Sharda University. Well, in India, when we start any cultural evening, we understand that, of course, in Japan, we always worship our gods. We take the proceedings with the help of our the prayers that we do for the god, right? In India, we do Saraswati Vandana. So Saraswati Vandana is the offering to our goddess Saraswati, and it is not just a fact, but we are really proud to say Sharda means Saraswati. Saraswati means education. And education means Sharda right now, and that's why we are proud to say Sharda University is among the best education provider in the entire country. Without any further ado, I want to introduce to Subhanshi Panda, who will be singing the Saraswati Vandana. We'll be offering the prayers to Goddess Saraswati. Over to you, Subhanshi Panda. Ek baar zordar taaliyan ho jaye. Have a big round of applause for Subhanshi. Yes, I will request everyone, please get up and please join us in the Saraswati Vandana. I know you cannot understand the language, but please understand the feeling, understand the heart, understand the culture, and we will believe that we will join our hands like this and we will sing among Suvanshi.
जयति जय जय मा सरस्वती जयति वीणावादिनी मा जयति जय जय मा सरस्वती जयति वीणावादिनी मा जयति जय पद्मासन माता जयति शुभकर्तायनी मा जगत का कल्याण कर्मा तू है ईश्वर काशिनी माँ जयति जय जय माँ सरस्वती जयति वीणावादिनी माँ जयति जय जय माँ सरस्वती जयति वीणावादिनी माँ. Thank you.
Thanks so much. Please have your seats. Well, we did something we did this. So this is also a symbol of respect, harmony. And when we join our two hands, we say, we are not just greeting you, but we are also here to say that we are together at Sharda University. And Sharda University will always say this, together, 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 beyond boundaries. Now, with the first performance, here at Sharda University, we have students from more than 95 plus countries. And of course, every country has a classical. In India, it is Indian classical. And we have our Indian classical troupe to show you the Indian classical steps, the majestic beauty of mountains, the Odissi culture, the Pahari culture, everything summarized in a beautiful and the most expressive way. Please give a hand to the dance club of Sharda University for the Indian classical. For this, I would like to invite Meghna from the Indian Classical Dance Club of Sharda University, who will be briefing us about the steps, everything, why we do this dance, and all the steps that is included in it. Please welcome Meghna with a big round of applause.
Good evening to all the esteemed delegates and the audience. It's known that India is a land of rich diversity and culture. The Dean Student Welfare of Sharda University feels privileged to showcase some of the many classical and folk dances that embody centuries-old stories, spirituality, and the daily lives of people. So first we have Suhani Pati performing Odissi. Originated in Odisha, it is known for its fluid movements and often depicting stories of Lord Jagannath. Next we have Sudipta Makal performing Bengali folk, which celebrates the joy and hardships of rural life with vibrant rhythmic steps and heartfelt songs embodying community spirit. Then we have Manika Lumba performing Kathak from Uttar Pradesh, famous for expressive facial gestures, intricate footwork, and swift spins blending Hindu and Persian cultural elements. Next up, there is Aditi De performing Lavani from Maharashtra, recognized for its strong beats and often humorous themes performed in vibrant attire. Our fifth dance form is Ghumar from Rajasthan, performed by Richa and Kshema, showcasing graceful features and circular movements with elaborate costumes. Coming to the next state, Punjab, we have Manya Dogra performing Gidha, a lively dance form performed by women to celebrate happiness with traditional folk couplets. Then we have Krishna performing Bharatanatyam, originated in Tamil Nadu, known for its precise footwork, expressive storytelling, and sculpturesque poses. Last but not the least, we have Garba from Gujarat, performed by Diya Agrawal and Gehna Elavadi. This folk dance, performed in circles, Garba celebrates feminine energy with rhythmic clapping and twirling. I hope that we would be able to show a small glimpse from the huge ocean of Indian culture, and you all love it. Thank you so much.
मला जाऊ त्यानं घरी वाजले की बारा 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 कनक प्रीत की सर पे ओढ़ कर घूमर घूमर घूमे हाँ घूमर घूमर घूमे ओ ललक रीत सब जग की छोड़ कर घूमर घूमर घूमे भर के भोला वाले ठाठ घूमर 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 घूमे घूमर घूमर घूमे रे भाई साहब घूमर घूमे आयो रे मारो ढोलना आयो रे मारो ढोलना रंगीलो मारो ढोलना ढोलना आयो रे मारो ढोलना आयो रे मारो ढोलना कूद पड़ा मेले में काया कूद पड़ा मेले में साइकिल पंचर कर लाया
सोने वर्गी कुड़ी खलोती झांझर पेशन कावे वे धरती नच्चे अंबर नच्चे धरती नच्चे अंबर नच्चे ने जदों मटकावे उच्चा लम्मा हौली हौली लाला टहलावे नचदा मुंडिया नीलिया बोलियां पावे नचदा मुंडिया नीलिया बोलियां पावे नचदा
ಕುಮಾರಿ ಮುನೈವ ಕನ್ನಿಯಳೇ ಬಾಣಾಸುರ ಭಯಂಕರಿ ಅಖಿಲ ಲೋಕ ಜನವಾನಯಿತಾಯೇ ಬಾಣಾಸುರ ಭಯಂಕರಿ ಅಖಿಲ ಲೋಕ ಜನವಾನಯಿತಾಯೇ ಬಾಣಾಸುರ ಭಯಂಕರಿ
बम पांजरो पहड़ो थयो एक सच्चर बम पांजरो पहड़ो थयो वाग्यो रे ढोल बाई वाग्यो रे ढोल मारा मीठा ना रणमा वाग्यो रे ढोल 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 वाग्यो वाग्यो रे ढोल बाई वाग्यो रे ढोल वाग्यो रे ढोल बाई वाग्यो रे ढोल वसुदैव कुटुम्बकं भारतं जयतु जयतु भारतं न्याय न्याय
तमसो मा ज्योतिर्गमय अंधकार को जीते मन यही प्रार्थना करता भारत विजयी भव मानव जीवन विश्व प्रेम की ओर चढ़ गया
Presenting
Well, breathtaking, right? So I think Bharat, India, not just a name, but an ideal, an inspiration. Something, of course, I know we all love our country. We all love where we are born. But for us, India is not just a country. For us, we call it our motherland. We call it our Mata, Bharat Mata. And this was our Bharat Mata ki Bharat Betiya, the daughters of India. Ek baar zordar taaliyan banti hai. A round of good applause for the daughters of proud India. A lot of cultures, a lot of dance traditions you have seen right now. But wait, is this all? Is all at us to offer? No. This is India after all. We have millions of cultures and traditions in the land, in the direct soil of motherland India. So coming up next, we have the Euphoria Club Sharda University. We'll be representing not one, not two, not three, but a lot of cultures, traditions, and not just India. There are some more countries too in that. I think you will love to see it. So have a big round of applause for the Euphoria Club.
Today, we are about to begin a journey of ethnicities where world connects and grows together. We have a breathtaking lineup from our Euphoria Club, the club which highlights culture and sparkle, the colors of joy, wonder and power. The power of culture, the power of us. As we come together under one roof, we are reminded that dance, like culture itself, is a universal language. Welcoming the electrifying cultural performances, which includes from the national to international, from the elegant grace of classical dances to the energetic beats of folk traditions. Please welcome with a big round of applause.
A big round of applause for Euphoria Club.
Nepali dance. often performed during festivals. This is a joyful expression of cultural heritage. Dancers wear traditional attire adorned with intricate patterns to honor their rich traditions and vibrant folklore. After the vibrant journey through Nepal, where traditions dance to the rhythm of joy, get ready to witness the majestic beauty of the mountains with the next coming up Pahari Dance of India.
की झावारी तेरी छुमछुमा बाजेली तू ता ठुमठुमा हिटली भले कुटियों की झांवारी तेरी छू छू में बजली तू ता ठुम ठुम ही डली तू तो बिगड़ेली खोडियोला सचे कन खेलो लागेली अरे पिफले डाली मुड़ी तू चौपली खेलीली चौपती खेलीली चौपती खेलीला
As we ascend to the serene heights, let the grace of Manipuri dance transport you to a world of devotion and divine elegance, with its unique attire embodying purity and tradition. Through the grace of Manipur, from the land of the mighty Brahmaputra, behold the spiritual splendor of Assam's classical dance, where each movement tells tales of Krishna's divinity.
বলাকাৰ দেউতাত সপোন ৰহন খনা দূৰণিৰ সাগৰ পাৰত বাজে বাঁহী মধুসনা
শুভ্ৰ বলাকাৰ দেউতাত সপোন ৰহন খনা দূৰণিৰ সাগৰ পাৰত বাজে বাঁহী মধুসনা
সমীৰে বজাই বা
after the divine intervention, now brace yourselves for the fiery energy of Tandav as the dancer wield the Trishul to depict Durga's cosmic power in this intense and mesmerizing dance. With hearts full of culture and awe, it's time to welcome the next showcase. On the ramp, let's cheer for Syria, bringing its timeless history and enduring spirit to life with every step. Marhaba from Syria. Next, Bangladesh, weaving tradition and innovation together in a tapestry of vibrant pride and energy. Assalamu alaikum from Bangladesh. From the valleys of paradise, Kashmir walks with a celestial elegance, radiating its serene beauty and grace. Adab from the heaven on earth, Kashmir. And wait, here comes Mexico, dazzling the stage with its bold colors and festive flair, setting the mood for a grand fiesta. Hola from Mexico.
Mexico. This hand-sewn costume represents a traditional Mexican crown. Something feels right about colors so bright. It's Mexico.
Gota, 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 gotita de mezcal, gota, 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 gotita de mezcal. Gota, 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 gotita de mezcal, gota, 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 gotita de mezcal.
And coming up next, Kerala, carrying the lush essence of God's own country, serenity and culture in every step. Namaskaram from Kerala.
ആരാന്നേ ആരാന്നേ ഒത്തുപിടിക്കുന്നതാരാന്നേ തീയാടാൻ തിറയാടാൻ മാണിക്കക്കാവിലുറഞ്ഞാടാൻ ഓനാന്ന് ഓനാന്ന് എത്തുപിടിക്കണതോനാന്ന് നേരാന്നേ നേരാന്നേ കൂട്ടിട്ട് വന്നതവനാന്നേ മണ്ണാന്ന് മണ്ണാന്ന് വന്ന് വിളയണ മണ്ണാന്ന് പോയോരും വന്നോരും ചോര പൊടിച്ചൊരു മണ്ണാന്ന് കതിരെല്ലാം കെട്ടണ് കെട്ടണ് കതിരെല്ലാം പാറ്റണ് പാറ്റണ് നിറ പറയണ നിറയണേ കണ്ടിര കണ്ടാരാ കതിരെല്ലാം കെട്ടണ് കെട്ടണ് കതിരെല്ലാം പാറ്റണ് പാറ്റണ് നിറ പറയണ നിറയണേ കണ്ടിര കണ്ടാരാ ആരാന്നേ ആരാന്നേ ഒത്തുപിടിക്കുന്നതാരാന്നേ തീയാടാൻ തിറയാടാൻ മാണിക്കക്കാവിലുറഞ്ഞാടാൻ.
And finally, Namibia is going to storm the ramp with powerful spirit and bold confidence. The wild beauty of African heartland. Omake from Namibia.
Utoto bala hushana mfana wa habeleza. Usakekeleza, usakekeleza, usakekeleza. Utoto bala hushana mfana wa habeleza. Utoto bala hushana mfana wa habeleza. Utoto bala hushana mfana wa habeleza. Barasa rumembera gele.
Only for hot gal in the place. Them want to wind them ways. Tell them forward in a ace. But the bang bang embrace, yeah.
Early morning love, she get it good from she rise. But put it on so good and make sure she call she ties. Smile upon her face, me know she pleased with this eyes. Coming around to meet them gyal a roll out them eyes. Go down there, why not go down there? Go down there, why not go down there? Go down there, why not go down there? Go down there.
Wine for your good makes it a drip off of me body, yeah. Oh, you full of chatter, you can't keep up with me energy. What a epic night of it, embedded in your memory. Little bubble up and treat it like a felony.
What you gonna do when there is nobody that do it better than this reggae guy? I can do this every morning, every evening. Have you screaming straight back to sunrise.
Just get it.
And this is India! Nowhere in the world! Keep playing the music! Everyone, get, join us, and go, 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 go! And go, go, go! Dance club, join us! Hello. एक और once more last once more करते हुए जाएंगे सब once more nobody we are not out of energy yet we are Indians full of energy and fire. Another Punjabi beat. Get ready, console. It's a punishment for the first. Another Punjabi song, another Punjabi beat. Last Punjabi beat. Like in second, something different. Come on, Nashid and Sushant over the console. Ready? Play. Yes. हाँ? दो? कौन है वो? कौन है? अच्छा, विकी कौशल का. हुस्न तेरा तोबा तोबा. Let's play that thing. Husn tera toba toba. Let's hear that. Okay. Let's go! Hey! Hey!
ਲਿਖਿਆ ਖਾਸ ਜੋਰ ਲੱਗ ਜੂ ਮਟਾਉਣ ਵਾਸਤੇ ਪੈਸੇ ਪੂਸੇ ਬਾਰੇ ਬਿੱਲੋ ਸੋਚੇ ਦੁਨੀਆ ਜੱਟ ਪੈਦਾ ਹੋਇਆ ਬਸ ਛਾਉਣ ਵਾਸਤੇ ਪੈਸੇ ਪੂਸੇ ਬਾਰੇ ਬਿੱਲੋ ਸੋਚ
Are, yes, this one.
ਲੈਂਬਰਗਿਨੀ ਤੇ ਕਿੱਥੇ ਲਾਉਂਦਾ ਫਿਰੇ ਗੇੜੀਆਂ ਜਰੀਆਂ ਨਹੀਂ ਜਾਂਦੀਆਂ ਫਰੈਂਡ ਮੈਥੋਂ ਤੇਰੀਆਂ ਲੈਂਬਰਗਿਨੀ ਤੇ ਕਿੱਥੇ ਲਾਉਂਦਾ ਫਿਰੇ ਗੇੜੀਆਂ ਜਰੀਆਂ ਨਹੀਂ ਜਾਂਦੀਆਂ ਫਰੈਂਡ ਮੈਥੋਂ ਤੇਰੀਆਂ ਵੇ ਪੋਟਾ ਪੋਟਾ ਪਿੰਜਿਆ ਪਿਆ ਹਾਏ ਪਿੰਜਿਆ ਜਾਂਦਾ ਏ ਜਿਵੇਂ ਰੂ
Well, that was energy. Remembering earthquake. This is India, Hindustan, Bharat, and once again, welcome, welcome, and welcome. Bharat Mata ki! Bharat Mata ki! Vande! Vande! Jai! Jai! एक बार Sharda gives you again. Sharda! Say Sharda with me. Sharda! 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 Okay. WPM! Okay, I'll say one word, you say one word. W! M! W! M! W! M! W! M! C! WPMC 27th edition, only in Sharda University, Great Noida, Bharat. Thanks so much once again. Shukriya, shukriya. And of course, thank you from behalf of all the students, Dean Student Welfare, faculties, our esteemed dignitaries, everyone that is involved in the entire event, Shanti ma'am, Pramod sir, Rachna ma'am, Suman ma'am, everyone in the console also, the performers, dance club, and Euphoria Club, and everyone there. Thanks so much.